everybody, and welcome to Spindle TV. My name is Laney Shaughnessy, and I am your host. I'm not sure why I'm still on the screen up front like that. Woo, okay. How are y'all doing? It's been a couple of weeks. I was supposed to have a class last week, but we were dealing with storms and all kinds of stuff, and I didn't have a class, guys and girls. But we are back. Gonna do a fun project, and hopefully it'll be entertaining for you, and hopefully it'll be informative. I mean, we're gonna do some designing, and we're gonna look at taking blueprints, if you will, and working with them, transferring them over into the Vectric software, redrawing them, if you will, to create things. We're gonna work with little building blocks, like Lego type blocks, building blocks. Make small ones for kids' toys. We're going to look at making some bigger versions for some stackable furniture and things like that. So it ought to be interesting. Before we get started and everything, I had a message texted to me with a question that I want to try to address with the individual Camaro, Calusa Cabinets. How you doing, buddy? With regards to him, his Vectric software and working with multiple sheets, he's kind of getting some kind of little anomaly that's occurring, and I want to share that with y'all, and I want to kind of talk with you. Keep in mind, hey, thanks, Brooks, I appreciate you. Keep in mind that we do have super chat down below if you want to pin a comment or question. If you have a general question, not obligated to use super chat at all. Just throw a couple of question marks in front of your question, and I can answer them for you. But also there is comments and questions and things, and stickers and stuff like that down in the fun, super chat and super stickers. But thanks, Brooks Martin, appreciate you for that. And all right, let's jump over to camera 2, and let's get bear with me a second. Let's get the screen cleaned up a little bit. See if I can get that lighting screen cleaned up a little bit. There we go. That'll be about the best it could get. All right, let's move me down into the corner. Let's see here. I want to go to there. All right. So, Camaro, at Calusa Custom Cabinets, Stephen was asking, with regards to he's working with multiple sheets, and when he would create the toolpaths for sheet 1 and everything, and have that, and then he would also have toolpaths for sheet 2 and have them created. But when he went to edit, if he right clicked on the screen over here after he switched to sheet 2, and he right clicked and went to edit, left click on edit, that it would switch back over to sheet 1. Now, of course, I can't recreate that. I've been trying since he texted me and everything. So what I am going to say to him is, what we want to make sure of is when we are switching from sheets, sheet 1 to sheet 2, see if this works for you or not. But if you're going to use the box, the Toolpath box over here, number one, make sure that you're up to date, because that could be a glitch in the version. We're at 11.503 right now. Make sure it's not like a little fix, like a patch repair, like a little glitch in the matrix that they've already found and corrected. Make sure it's not that. Make sure your version's up to date. But also, if you're going to use this over here to switch, to, let's say, sheet 2, make sure that it does switch to your new toolpaths, and when you go to edit and everything, make sure that nothing on sheet 1 is selected or anything like that. There's no check marks, because it might actively that pull it over. I'm not sure. I'm just kind of speculating now, because when I go to edit, it stays on sheet 2. It doesn't switch over. If that doesn't work for you and you're still getting switched over to sheet 1, you can get with me one-on-one. We can jump on TeamViewer, and I'm happy to take a look at it and just see if it's something that I see that you're missing or something, or it could just be something in the software, right? We could figure that out too. But also try switching, double-clicking on your sheets here and then going over checking the toolpaths and see if it keeps switching you back. But the see if it switches you back when you come back over. And let me get back out of that. Close. When you come back over to edit, a toolpath, I kind of have a feeling that somehow or another it's actually editing. When you're clicking on edit, it's editing or trying to edit one of the toolpaths from sheet 1 for whatever reason. Make sure that you are not on all sheets, right? And you're clicking, make sure you don't accidentally click all sheets, and you're not clicking on, here to where when you click edit, it automatically brings you back to sheet 1, because that's going to happen. If I'm on, I was just on sheet 1 and it brought me back to sheet 2 because that's what was edited. And all. So can you guys and girls hear me okay? Everybody can hear me all right and all that good stuff? Okay, good. All right, so I'm going to ask you folks to bear with me 2 seconds. There's someone that keeps kind of calling, and I've sent them a message, but let me send them another message. I'm currently in a live class on YouTube and cannot take phone calls. I'll be available after 10 p.m. Okay, cool. Cool beans. Never ending. Let me just make sure that was the right phone number that I just texted. Yes, it was. Okay. So, anyhow, Stephen, make sure, let me close out of this again, just kicks and giggles. If I was on, sheet 2 here, right? And I come in and I'm accidentally in all sheets, and then I come in and, right click and edit, make sure that it's not something that is going to throw you back into, out of that sheet into another sheet like it just did me here. Make sure you're not in all sheets. That's the only thing that I can think of, because if I'm in the individual sheets and I say, let's go to sheet 2, and I click edit on that sheet 2, it's going to edit sheet 2. It's not moving me back. So I don't know, but work with me. If you can't figure it out and it's still doing it for you, work with me one-on-one. Let's get together and work together one-on-one and see if we can't figure out whatever it is. Okay. Brooks Martin, customer supports 24/7. Oh well, 24/6. I'm closed on Sunday. And customers still get support, but I'm having a live class, and I will get back with that customer as soon as class is over. But they're still going to get supported tonight. I'm not sure. Bear with me for a second. Customer supports 24/7. Oh well. Let me know what that means, Brooks. All right. But those customers will get served after everybody. I'm up till midnight, 1 o'clock, helping everybody after class on Tuesdays when I have class. All right. So, again, Calusa, Custom Cabinet, Stephen, get with me when class ends, call me, and let's see if we can't jump on TeamViewer. It's a remote assistance program I use with customers. Let's see if we can't jump on TeamViewer and let me get back in the camera here and figure it out if you can't, if none of that worked for you. Okay. All right. Now let's close out of this and let's go into projects that I'm working on here. So let's go into, You guys and girls, many of you probably have seen me work on SketchUp before, and you've heard of SketchUp and things like that. And all, we're going to be working with kind of a Lego building block, and we're going to be able to scale this up or down to different sizes and everything. And the we're going to take the concept of the Lego block, and we're going to be able to make stackable furniture and drawers and stuff. You might see those online and everything. Thought that was fun, but the build is actually more different than you're going to think. And so we're going to lay all that out. We're going to do toolpaths and all that stuff a little bit later. So we're gonna look at laying out the parts for these drawers. If I come in here and move and pull this up, you can see that the lid is separate from the holes here. Let me see if I can. Let me see if I can grab them. Grab those. Not you or you. And move that up. I grabbed more than what I wanted to, but we've got rabbet joints and things like that we're gonna do. Let me put that back. And the cutouts from the bottoms, you know, so the parts can stack together, right? So let's grab this piece of here and turn it around so you can see. So parts will be able to stack together. Neat little drawers and things like that you can make. We're going to work on that tonight. It's going to be fun and easy. But first, let's make the layout from a blueprint, working in millimeters to inches. So you're going to learn how to convert from millimeters to inches and all that stuff. We're going to lay out the Lego, the part itself, the actual part, to scale. And then from there, we're going to scale it up. So let's get back into our Vectric. And this is a blueprint, if you will, of from a CAD/CAM class where they use Legos to kind of teach CAD/CAM designing and stuff like that. And so we are utilizing the measurements, and all this is in metric. We're utilizing the measurements from this drawing to recreate our own. Now, as you can see over here, I already have one, and then I have a scaled up version over here and everything. But we're going to start from scratch because we're going to look at drawing and creating our parts, right? So, question for you guys and girls, show of hands and things like that. Thank you, Calusa Cabinets, for the super chat. Wow, for that. Awesome. What am I trying to say here? How many of you use the calculation edit boxes and the variables? You know, the X and the Y, or W and X for the width of your material, the H and the Y for the height of your material, the T or the Z for the thickness of your material, the multiplying by I or M to convert from metric to imperial. Do y'all, how many of y'all have used your calculation edit boxes for that? If not, you're going to get a lesson in it. We're actually going to be using that quite a bit here in this, and it's something that's very useful. Okay, cool. Great. Mainly just the Z equals, right? So for like doing a, you know, let's say a profile cutting all the way through, Z equals and that kind of thing. Yeah, awesome, cool. Roger's never, and Rodney is, yeah, here, okay. Cool. Here's what we're going to do. We're going to start off, and let's look at our layout here. And let's start off with this figure in the top right corner. And let's look at what we've got going on here. And so this is going to be a 8-piece Lego. And from there, you know, you could do a 4-piece Lego, 6-piece Lego, the single row Legos, all those kind of things, right? So we're going to start with the main design, and then we can break it down from there, right? Cool. And bear with me just a second here. All right, cool. And let me All right, sorry about that. We had someone in the chat that goes from there. All right, now let's start with this. So first thing we're going to look at, let's get our circles laid out, right? So our circles are 4.9 millimeter in diameter in this particular drawing. Now we're going to be working really on a small scale, like an actual Lego, and then we'll scale it up from there. So, but we're going to work off of our dimensions here. So our diameter of our circles are 4.9 millimeters. Their spacing from center to center is 3.93 millimeters. Okay, and their I'm sorry, they're from center to center is 7.98 millimeters, and their spacing from the edge of our rectangle to the center of our first row of circles, if you will, or first column of circles, is 3.93 millimeters, and then our spacing between the rows 7.98 millimeters. So all of this stuff is like, ooh, okay, here we go. All right, let's get it going. So we're gonna kind of work up here so we can look at our numbers at the same time. We're going to start with our circle tool, right? And we're going to work with diameter. And here's where our calculation edit boxes are going to come in handy. So we're going to take 4.9 millimeters and multiply it, that little asterisk sign, multiply it by the letter I for imperial and hit equals. Okay? All right. So the 4.9 is the millimeters, and we're multiplying it by the letter I to convert from millimeters to inches. If we were going from inches to millimeter, we would multiply by the letter M. Okay, so 4.9 times the letter I and equals. All right, cool. So now we can draw our circle. So there's our circle right there. Okay, and the we're going to now get them kind of spaced apart, right? So I want to come over here, and I'm going to use my array tool, right? The array tool for this, and we want 4 columns, 2 rows, right? So 4 columns, 2 rows. Okay. Now on the X, the gap, okay, we have a choice of offset or gap, right? And I would love, Vetric, if you're listening, to have a spacing of center to center. Would love it. Would love it, right? Center to center. That would be awesome. You know, work with me on that. So for that, in order for me to get the correct spacing, since it's the gap of the right side of an object to the left side of an object, right? I would have to, you know, take, in this case, I'm going to hit Control-C, Control-V, and, oh, let me close this tool, right? Control-C for copy, Control-V for paste, and that's going to paste a circle right on top of it, right? And then I'm going to move that relative to its position, 7.98, and let me show you where that number comes from. That's this number here, spacing center to center, okay? So 7.98 times I, because that's in millimeters, equals. And I'm going to click apply. Okay. Now, when I do a relative measurement and everything, I'm hoping that if all is well in the world, when I measure from center to center, I'm at 0.3206. And 0.3206, let's go back into our, we'll pick a box, our move box, it'll be fine. 7.98 times the letter I equals is 0.314173, right? So where does 326 come from, right? That's because it's not moving from center to center. Vetric, work with me, please. Okay? So what I want is to, I'm going to grab a guideline and snap it here. And then I'm going to create a relative guide. 7.98 times the letter I and hit equals. Okay. And You see that? You see what throws me off here, Lord? That's the perfect layout, right? So it is going from center to center. Sorry, Vectric, didn't mean to give you a wrong deal. But when I measure horizontally from here to here, is it giving... Now it's giving me the right number. What? Somebody say hello. Welcome, Lord. Okay, so we're there. All right, center to center. Now that I've got that laid out, if I were to measure, God help me, let's do this one. From the right side of this part to the left side of this part, that is my gap, right? 1.1213. Okay, that's my gap. All right. And what's easiest for me, and you can ask yourself what's easiest for you, since we're using the array tool, and the array tool doesn't really have, center to center and all that stuff, but our dimensions are kind of based on that. We need to kind of work with that kind of deal. It's easy for me to just get my 4 circles laid out using guidelines and snapping to guidelines, right? What I mean by that is if I come down here and I snap to the center, I have that one circle, and I'm going to get rid of this for a second. And on this guideline here, I want to create a relative guide that is 7.98 inches. And again, that multiply that by the letter I. And I'm going up. It's a positive number, so I'm going to create that guide. And where that number is coming from is right here, the space center to center in this direction, just like it is center to center here. Everything is nice and uniform. So for me to lay out, and let's get rid of this one out of the way, to lay out those, and then to be able to lay out, let's get rid of this. I want to delete this to show you. Here, close. If I come in here and I say, okay, I want to do a relative guide, and I want 4 of them, like 4 rows, I can create those 4 guides just like that. And then it's just as easy for me to hold down my control key and drag and snap the circles from center to center on here, instead of taking the 20 minutes or 10 minutes or 5 minutes or whatever it is to do the math to figure out what the gap or the offset is and all that stuff. Now, of course, it's not that difficult to do the math and stuff, but it's just as easy for me to lay it out this way than it is to try to do the array. But if I was trying to do the array, I would want to know what the gap spacing is. And then I'd also want to know on that gap, from the bottom of one part to the top of the other, it's going to be the same thing, the 1.1213. So if I were to measure that vertically from here to here, from there to there, okay, same thing. The spacing is the same because the numbers are the same. If I were to, if I knew those 2 numbers, then I could come in here and select my circle, come in here with the gap of 0.1213, 0.1213, 2 rows, 4 columns to create that, part again, right? So either way, whatever makes it quick and easy and dirty for you. Okay? But I would love a center to center metric instead of a gap or an offset. Offset measures from the left side of one part to the left side of the other part. A gap measures from the right side of one part to the left side of one part. I just want center to center, right? That would be awesome. All right, let's put a petition out for that one. Okay, let's get rid of the guidelines. Now, once we have our circles laid out, and we can turn the guidelines back on. Once we have our circles laid out and everything, then we can figure out our rectangle. Now, if we look at our rectangle, from the center of our first row to the edge of the rectangle is 3.93 millimeters. And that's also the same for the space between the center and the side edge, 3.93 millimeters. Okay, so I'm going to take this and I'm going to create a relative guide up 3.93 times the letter I and create that guideline there. Okay. And then the one on the side, I'm going to come in 3.93 times the letter I and hit equals. I only need one. And it's going to be a negative number, so it's got to go to the left. So it's a negative number. Create that guide. And that'll give me this box here. Let's get rid of these so you're not confused of what you're seeing. And then over here on this side, 3.93 times the letter I equals. Oops, relative guide. All right, let's try that one more time. Work with me there, Haas. 3.93 times I equals, and then create that guide there. And then last but not least, create a relative guide, 3.93 times I, and it's going down, it's a negative number to create that. Now I can take my rectangle tool and just draw that rectangle to create that part. Let's turn off the guidelines to see where we're at so far. Okay. So now we have the main layout done. Let's go ahead and make this an actual piece of wood that's going to get hollowed out and pocketed on the other side. So let's take a look at our, let's move this down here. And let's zoom in to these two parts. Okay. And so the space that we have, the space or the offset is 1.48 millimeters. 1.48 millimeters is the offset on all four sides. That number is right here. You can see our lines here, 1.48. And so our offset going outward is going to be 1.48 times the letter I for imperial and hit equals. And we want square corners, select new, and we want to create that offset. Okay. Now, our larger circles, if you know how Legos work and stuff, let's come over here. And let's turn this a little bit. The larger circles that are in the middle and everything, the circles that snap together, they snap in between, they fit into these little openings and stuff. So these circles on the edges, if we look at this diagram, are round pegs that we just created. They're going to fit, you know, around this. That's what holds them into place and everything. And so from here, our circles, our larger circles and stuff, we have a 4.07 diameter inner circle. They hollow it out to make it less weight and stuff like that, just less material needed and all and everything. But so we're going to have a circle that is 4.07 diameter, 4.07 times the letter I for imperial, because it is metric. And we're going to come in and now I have smart snapping on and everything, And that doesn't mean that I can create a cool little snap point and stuff, but I can create kind of a bit of a guide, but I'll snap them together in just a minute. And I'll try to get it in the middle, perfectly middle. I'll show you how that goes. Now, the outer circle is 6.38 inches in diameter. 6.38 inches in diameter. And is this a JPEG, Charles? This is a JPEG, but it's from a PDF. So the PDF, if we were to look just really quick to answer that question, where this excerpt is pulled from is a PDF online. I'll make a link to it and everything, so you guys and girls will have a link to it and stuff. But the PDF, when it loads, that did not load properly, so we're going to do it again. Why are things not working like they're supposed to? There we go. So it's from an educational document teaching CAD modeling using Lego, right? And so it's an educational instruction that talks about Lego design and concepts and things, using the original Lego and then creating their own, designing their own custom parts. Get back up here. Oh, come on. Designing their own custom parts that actually snap to existing Legos and things like that to make cool things like these little soapbox type racer cars and things like that, right? So it's a CAD, a lesson class, and they were using Legos as the concept. So we are using the excerpt, and I'll put a link to that PDF for you guys and girls, but we're using the excerpt of the Lego document, right? Cool. And so back to where we are here. So our outer diameter is 6.38 millimeters. 6.38 times the letter I equals, and then we're going to come in here and get to the center of our circle and snap to it, right? Now we're going to group the two circles together. We're going to select these four circles and we're going to group them together. And I'm hitting G on the keyboard, but group is over here, the fourth icon on edit objects, group and ungroup, or the letter G for group on your keyboard or U for ungroup. And now we have this group of four and we have our circles, this group of two. We're going to select the circles first and then our group of four last. Hold that shift key down and we're going to align to the center. Okay, we're going to align to the center. Now, the spacing, if we go and look at our design here, the spacing center to center is 7.98 from center to center, 7.98, and the millimeters and all. We can simply take our circle and put a guideline over here, 7.98, that type of thing. Or what I'm going to do, something a little easier for me, I'm actually going to ungroup these two circles, right? I'm going to deselect these two and reselect these two and group those back together. And I'm just going to select this, Control C, Control V to make a copy and paste it. And it's pasted right on top of it right now. And I'm going to, with this selected, I'm going to select this new group and I'm going to align to center. Okay, so my copy pops over there. I'm going to come over here and I'm going to hit the letter U to ungroup. I'm going to deselect these two, reselect these two, group G for group, and I'm going to do it again. I'm going to select this and hit Control C, Control V, copy and paste. We copied it and pasted it right on top of it. With that selected, I'm going to come over here and select this group last and align to center. Simple enough, right? Right. Cool beans. So now we have all the makings of a Lego part, right? So our toolpaths will be determined by, our pocket depths here and things like that. We'll be able to use these figures to figure some things out, our cavities and all that stuff on the backside. But first, let's go ahead and this is what our Lego looks like. Now, this guy in inches, right, in overall size, this is only 1.36 inches by a little under 3/4. If we measured, it is overall measurement from here to here, and from here to here. Okay, so that is our overall measurement on this guy and everything. And I want to scale it up a little bit, right? I want to scale it up because I want to make a bunch of little blocks. I literally want to carve these using either a 16th inch end mill or an 1/8 inch end mill, one of the two, whichever one fits, best and all. We're about to lay it out and do the toolpaths here in just a minute, you'll see. But I want to scale it up, and I want to make some of these of different species of wood, walnut and maple and cherry and different things, and make little building blocks, a little kit for my, niece or nephew or son or daughter or whatever, kids, right? That kind of thing. So, but right now, utilizing the specs, this is the size. Now, keep this in mind. This is an 8-piece Lego. If I wanted it to be a 6-piece Lego, I would just eliminate these 3 components here. And then I would make sure that my rectangles were moved over and had the appropriate spacing from the center of this row to the outside, right? Get my spacing exactly right. And now I have a 6-piece. I could do that with a 4-piece and so on and so forth. I can make different pieces. This is our main piece, our 8-piece Lego, and from there I can go 6, 4, 2. I can cut it in half and go with the little individual skinny, ones as well too. So that kind of thing, right? So keep that in mind. Let's get rid of these numbers, and I would like to, if I came in here with an 1/8 inch end mill, right, 0.125, oops. Right, I'm going to drop an 1/8 inch end mill right here. And I could have a 16th too, right? It doesn't have to just be an 1/8. But imagine that I'm coming in here and carving and stuff. An 1/8 inch end mill just doesn't quite squeeze through this here. So I'd have to use a 16th inch end mill if I want to make a piece this size, this scale. I'm just going to bring it up just a little bit. Right? It's kids. I want them to be able to kind of handle them and all. I don't want little small pieces, just a little bit bigger, like a little kid's kit, right? So I'm going to take this scale, and when I size it, instead of using the inches and all, I can use a percentage, the percentage. Currently right now what I have selected, it's 100% of its original size. Now, I want to keep the original intact, okay? So Control C, Control V, when I close this tool, before you do that, but I want to hit Control C, Control V, and I want to make a copy of that, and I just want to drag my master somewhere, and I want to put my master on its own layer. So I'm going to move to a new layer, and I'm going to call this my master Lego, because we still have to do, it's a 2-sided project. We still have to move things to the other side and all, right? So master Lego or building block. I don't want Lego coming after me, right? Master building block. Don't come after me, Lego. All right. So, I don't need that visible right now, so I'm going to turn the visibility off and click OK. So I have that intact on another layer. Don't need to worry about it, right? Cool. Now I want to take my copy, if you will, that I have here, and I want to size it up a little bit. And I want to go by percentage. And so I think I'm going to go 1.5. I'm just going to go up 50% of its current size right now. So just a little bit bigger. So if I went up 50%, its current size right now, okay, and that was stupid of me. It's got to be 150. Add the 100 plus the 50. 50%, I shrunk it down. I want 150%. I knew that. I just don't know what I was thinking. I want to just bring it up, right? Now, I want to look at the measurement of this. Now it measures about 2 inches long, a little under 1 1/8 high. So, again, we can, just so you guys can see the measurements in big numbers and all that stuff, we are about 2 inches, a little over 2 inches long, 2 1/16 roughly, close to, not exact, and by about, a little under 1 1/8. And that's good. So, imagine, I don't have a tape measure here handy or whatever, but 2 inches, I've got a ruler. What am I thinking? I'm set. So that is a block about yay big, right? So not very big at all. So yay big, right? 2 inches by 1 inches. So that'll be cool. That would be a good size little building block. And I can make a bunch of those in different sizes and all. I can go bigger, right? If I want to make jumbo blocks, right? If I want to make jumbo cool building blocks for the kid for the backyard or something or whatever, who knows, you can go bigger. If I wanted to make a wall of Legos, I could go bigger, right? I'm just making like a little bag of Legos of wood, made out of wood, different species of wood that they can put together. I'm not making a race car or anything. I'm not designing Legos to complete a complete race car. I could, right? But that would be very involved, like what pieces I'm going to need to make and all that stuff. You could, right? Or a log cabin or things like that. I just want them to be able to kind of build something with it, a little box or whatever, right? So I'm going to have just a bunch of these different things. And they might be 8 pieces and 6 pieces and 4 pieces, whatever. I haven't decided that yet, but right now I've got my master. Okay? So that's kind of where we're at. All right, so I've got it sized up, and I'm happy with this size for right now. So my measurements, let's get rid of those. And now, okay, now I'm going to bring this over here, all right, and I want to size my board up appropriately now. Okay, I'm not going to be using it out of a big sheet like this. This board that's here is a 12 by 12. If I was going to cut these out of multiple pieces and all, I would need to know they're going to be 3/4 inches. 3/4 inches thick is fine. But I need to determine what size board I want to cut these out, because I want to do like an array of them and that kind of thing. So for this, I will add another sheet, a second sheet. So I'm going to go Sheets, New. And on this sheet, I'm going to assume that I'm making these parts out of a 1x8, right? So my CNC can cut long lengths up to 36 inches is good for final cut and all, but I'm just going to go 24 inches. Okay, so I'm going to edit this, and we're going to go 24 by 7 1/4, because that's 1x8 by 3/4. Now a 3/4 inch block, right? So I don't have, I do have a piece of wood, right? Oh. So I'll use one of my old drawings as an example. So 3/4 inch block, right? So those are quite small. If you mill your own lumber and all, run through a planer and all that kind of stuff, you're milling your own lumber of different species, walnut and maple and cherry and things like that. You've got some rough sawn lumber. Think about going 1 inch. 1 inch would be a good size, a good tall block. Because remember, you got the little pegs that stick into the other one and everything, right? So this is going to be, you know, quite small and everything, you know, as a 3/4 inch one. But think about 1, even 1.5 inch, that kind of thing, you know, for your building blocks and stuff, right? Okay, bear with me just a second. All right. So the from there, bear with me just one moment. We had some spillage on the floor. Okay. The so think about that. Think about what size your blocks are going to be and stuff like that. And if it's 3/4, if that's all you have access to, hey, that's fine. There's nothing wrong with that. If you are milling up different species of lumber, just kind of think about maybe going 1 inch, 1 1/4, 1.5, that kind of thing, because that'd be a cool, tall, decent block, right? You know, and all that stuff. But it doesn't have to be crazy. I'm just going to go 3/4 just so you guys and girls can get the concept, and then you know you can scale your thickness up and all that from there. Now, this is a 2-sided project. I'm going to be touching off my Z on both sides, the material and everything. I will be starting from the center. That'll be fine, or the bottom left corner, your choice. I am going to the sheet be okay. And I'm going to be flipping along the y-axis. Okay, cool. Now, let's pause for a second and let's see here. Michael's in the process of making a bunch of blocks right now. Cool. Yes, Mike Scott, we'll do a file share. You'll get the files on this. We'll share that. 6 inch tall fusion block with my Lego. There you go. Cool. Awesome. All right, so this is what we're gonna put our blocks on and everything to cut them out and stuff. So let's go back to sheet 1 and let's take our block here and let's copy it over to sheet 2. Okay, let's get it over here. All right, coming back on sheet 2 now, I'm going to do an array of things. But before I do that array, I want to make sure that things are grouped together because once everything is laid out and stuff, I'm going to be moving things to the other side. Okay, so what I'd like to do is on here, I want to make sure that my 3 circles, because those are going to get sent to the other side, I want to make sure that those 3 objects are grouped together as one for myself. And then my circles here, I want to make sure that those are grouped together. So I'll group them, and I'll just select both of those groups and group them together again, so they're kind of grouped together. And then the 2 borders I'm okay with, I don't need right now. Now, the array, we're going to do an array of these to just kind of lay them out. Basically, I want to go, these are 2 inches, right? So I'm going to go at least 11 across because I have 24-inch board here. So I'm going to go, let's go 11 rows, 11 columns. I don't know why I keep saying rows. 11 columns, and I think I can get 5 rows, 6 rows out of that. And I'm just going to put a space in between, of, I'm going to be using an 1/8 inch end mill, so I'm going to go 1/8 and 1/8 of the quarter between the 2 parts, plus another 1/8. Let's go 3/8. That's fine. Okay, and that is going to be my gap between the parts, and let's create that array. Oh, okay. I didn't take into account the spacing and everything and how much spacing there was going to be. So too many rows, too many columns. I can delete what I don't want, but I'm just going to back that down. Okay, I can actually get one more row out of that. I'm good with that. All right, let's get those centered on the board because I don't care that I'm, that close to the edge. That's wonderful. That's good. Very little waste and all that good stuff and all that good jazz. Now, okay. Now I'm going to come in and I'm going to select all of my center circles. Now notice, because everything is grouped together and all that stuff, I don't have to worry when I'm selecting these objects. When I draw my selection window, as long as it's 100% in the box, in that window, it will select it. Anything else, it will not select. And so I can just simply draw a selection window down this entire row to select that entire row, right? Hold my shift key down and let's do it again. This row and this row and this row. As long as my center circles that I'm trying to select, those big ones, as long as they're 100% in the window, that's all that's going to get selected, right? So I am now going to move those to the other side. It's a two-sided project. Move it to the other side. Okay. Now we're starting to kind of look like a Lego here in just a minute. All right. Now, when I come in and do my pocket cuts, I'm going to do a pocket cut that's going to create these pegs, right? These little pegs. I got to mill the material around them away to create those little pegs and stuff. So I want my router bit to give me clean edges. When it's cutting this and everything, I don't want to just do a pocket in here between these circles and this border. I don't want to just go there because I won't get a good clean edge here. So I'm going to create an offset outward on the outer boundary, just a small amount for my pocket toolpath. And I should have done that. Foresight tells me that I should have done that before I done my array, right? And everything. That way I don't have to sit there and do, select each one of these and do the offset, independently. Well, I am going to just select my outside border since I'm kind of already here. I could, hey, it's just as easy for me to go Control Z to undo, Control Z to undo, and go right back here. Control Z. Take this object and create my offset on it. Outward, a small amount. I'm going to go 0.03125, a 32nd. Square corners and offset that outward, and then rearray these, right? But with that, it now takes my spacing a little bit too far, right? It presses it out too far and stuff. When the other spacing was perfect, because this rectangle that we're using is just going to be for a pocket cut. So it doesn't matter that the whole top's going to be round. So I am going to undo that. I'm just going to array my shapes. This is my thinking, my logical thinking. I'm going to center those on my board. I'm going to take my center circles and copy them, or move them, not copy them, but move them to the other side. And let's try that again. Move them to the other side. We'll get that row. There we go. Right click, move to other side, right where we were just a minute ago. And then when I create these offsets, they're just for the pocket toolpath. So I don't care if they go off the board and all that stuff and everything. It's because we're going to be milling basically kind of that surface off to create the pegs. So what I'm going to do is I'm just going to draw my selection window from right to left, and anything that my selection window touches, it will select, right? So I just want to make sure that I'm touching only the outside border. Okay? Hold down that shift key, and I'm just going to go from right to left. And I'm going to give myself a twofer on that one. Right? Right. I'm starting over here and on right over. Let's zoom in. I'm starting over my mouse over here, drawing, holding down that left mouse button right to left, and anything that it touches, it's going to select, right? So start here, right to left, select that. Come in between these two, right to left, come up, select those, slide down a little bit, and finally select those, right? And it's just easy for me to do that. Now that I have them, I'm going to hit G on the keyboard to group them together. In case I click off somewhere by mistake, it's easy for me to just reselect them, right? G for group. Cool, cool beans. Now I'm going to offset these outward just a little bit, and this vector that's going to be created is simply going to be for the tool path, okay? Simply going to be for the tool path. So I'm going to offset outward a 32nd. Create square corners is fine. Offset. Perfect. Now that offset is selected, so while it's selected, hit G for group. That way I'm not sitting there having to, try to select these things again when I go to create the tool path and all that stuff. There, all I have to do is click on one, and they'll all be clicked together because they're grouped. G for group. Yay. G for group. Yay. Go group. Okay. All right. Let's create some tool paths. Okay. All right. Let's switch over to the toolpath side here. We're going to have our outside profile selected and our circles, right? All of our circles. Okay. So these guys here, we want to make sure, remember, they're grouped together, right? So if it's not 100% in the box, it will not select them. So all I have to do is just go through just like I did with my middle circles and select those bad boys. One row at a time because they're grouped together, right? Once I have all them selected, let me do that last row again. Once I have all of them selected and everything, hey, it's just as easy for me to, let's get rid of that rectangle. I have a few rectangles in there selected. This whole row of rectangles got selected by accident. Bear with me. Be careful of that. Make sure that when you're selecting things, you don't accidentally grab what you're not wanting to. Okay. But here it's easy for me to turn that off for a minute. Hit G to group all those circles together. So now when I click on them, they're all selectable at one time. And then come back in here and select that outside border, and it selects all the outside border. Group, 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 right, when you can. Cool. Now, pocket toolpath. Okay, how deep does our pocket need to be, right? So let's take a look at this. Now, by scale on the smaller ones, right, it's 0.189 millimeters, right, is our height of our pegs. Now, if I come over here, I'm going to use the collection, one of these value boxes just for kicks and giggles, and I'm going to type in 1.98 times I and hit equals, and that's 0.077953, so a little over a 1/16 of an inch tall. That's how tall those are and stuff like that, right? Well, I am, I've scaled up, okay? I've scaled up the design here and everything, and I just want a height that is going to be a good height for the parts to be able to snap together, right? I think either, in this case here, 1/8 of an inch, I think that would be good. Where's my handy dandy ruler at? I think 1/8 of an inch or even 3/16, right? Either one of those two. Let's take a look and see which one we like best. Let's start here with a pocket cut. We're going to go 3/16 of an inch with an 1/8 inch end mill. Do an offset cut. And we're going to call this our little peg forming. I don't know. Peg forming is fine. All right. We're going to calculate that. Toolpath. Okay, let's preview that visible toolpath. Now, mind you, remember this, okay? When we cut these parts out and all, we've already, now our pegs are, if we went 3/16 on our pegs, right? 16/16 is 1 inch, and 12/16 is 3/4. That's what we're dealing with, 12/16, right? I've already just used 3/16 of that for my pegs, and so that leaves me with a block, not counting the pegs, that leaves me with a block that is 9/16, which is a little over 1/2 inch tall. So this is why, like I said, think about like a 1 inch block, or what have you, think about that and stuff. All right, let me stop here. Do not forget to save. Yes, I'm going to hit save on this right now. Thank you for that. So that's going to be our peg formation, right? And again, 3/16 might be a little much. 1/8 inch might be just fine. This is where we would, I'm going to be carving a one block, and I'm going to be testing everything. Cutting that one, it's 2 blocks actually. I'm going to be cutting 2 blocks, and I'm going to be testing everything, how they fit together and stuff. That's going to tell me my offset allowance that I'm going to need for when I'm doing my pocket cut on the back side, so the pegs fit in, and they snap in and all that stuff. It's going to tell me a lot of different things on my cut. So I might create a small block with just 2 of these, cut them out, and then that's my trial and error, do some testing and stuff, and I might find that 3/16 is a little bit much. It looks like a little bit much here. Lego pegs aren't that tall, right? I don't think I need them to be that tall and stuff. So I might back down to 1/8 of an inch. So I'm going to come back in here, and I'm going to back that down to 1/8 of an inch. I'm going to reset that preview and preview that visible toolpath. But again, at the same time, we also want, when they snap together, we want them to hold together, and we want it to be able to build like a little box or whatever. I don't know, whatever they build, and everything sticks together, right? Try to use dry wood as much as possible, because you will get some wood movement, right? Even on something that small. All right, we are rocking and rolling. So I think those pegs look much better. Okay, now, really, that's all we have to do besides the profile cut. Okay, that's all we got to do besides the profile cut. And so on the profile, that's the actual, the second one in. This one was just used for the pocket. This vector here was just used for the pocket. This is our actual outer border. And notice they're all grouped together. That's where grouping comes in handy. I'm going to do a profile cut, but I'm only going to cut halfway through. Okay, halfway through. So, profile cut, cutting 3/8. It's a 3/4 inch board for me, right? So 3/8 of an inch. I'm going to stick with my 1/8 inch end mill through all this. I have the Speed Tool, guys and girls. Have you guys tried the Speed Tool? SPETOOL. I'm not sponsored by them or anything like that, but they're on Amazon. I bought a few of the Speed Tools, 16th inch end mill, 1/8 inch end mill that was extra long with a 1 inch cutting flute, 2 flute upcut spiral, downcut spiral, and compression. Good little tools. I have no complaints on them whatsoever, and they're much cheaper, right? I'm all about it, and they're doing well as far as lasting and stuff, and everything. Hang tight, 2 seconds. Hold on. And we are back. And so the tool that I'm going to be using is this Speed Tool, 2 flute upcut spiral bit right there. So 1 inch cutting flute, good length, and 1/4 inch shank, of course. But yeah, so SPETOOL on Amazon, not a bad tool at all. All right, so we are going to, I'm going to stick with the 1/8 inch end mill. We're going to be cutting on the outside of the line. On this part, I kind of don't want to do tabs. I really don't want to do tabs. I think I'm going to do kind of 2-sided tape. I don't know. But when it's all said and done, now I'm only cutting halfway through, so I don't need tabs right now. But I don't know if I want to do tabs. If I do, they're going to be very small because I don't want to do a whole lot of sanding, right? You know, all that stuff. I might use two-sided tape. Sorry, I had the hiccups. But I haven't decided that yet. That'll be something I decide when I'm actually carve my samples and decide if I want to go through that. If I did add tabs, okay, if I did add tabs, they'd be about a 1/4 inch wide and they'd only be about a 1/16 of an inch thick. One side is 1/16 of an inch thick on the other for a total of an 1/8 inch thick. And if I edited the tabs, I would automatically do them so I didn't have to kind of click, 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 you know, and all that stuff. I'm going to just do 2 tabs for each part. I'm going to avoid corners and curved regions, and I'm going to click Add Tabs. All right, to let it add those tabs and everything. Now, the tabs on the outside are absolutely useless, right? So those tabs on the outside of the parts are absolutely useless. A much better orientation would have been, you know, putting a tab here and here and here and here. Vetric, Lord have mercy. Okay, but they didn't. They went up and down. So let's undo that. And bear with me a second. For the most part, there's no sense whatsoever for those tabs to be there. So let me go through and remove them. Hold on a second. Be careful what you're clicking and what you're doing and stuff. Because in that little, you know, just thing, I accidentally moved all my borders, right? Don't do that. Okay. So edit tabs. Let's come in. I'm going to get rid of these. Bear with me. Let me just go through and get rid of these on this edge. If I'm going to, you know, if I would did that, then I'll go with a wider board or something, but no. Okay. So imagine that those are the tabs if we're going to do tabs. Whatever. I prefer not to do tabs, but that's okay. All right. Let's calculate this. I think, you know, two-sided tape would be the way to go for me. All right, so that will be, if we preview that visible toolpath, I'm still undecided. It's one of those things like, I don't know, because the two-sided tape has to be able to also hold the other side that's only just pegs, right? And all that stuff, you know, something to think about. Okay, so there's our board. Now, we are flipping this board, so we have to think about alignment pins, alignment pin holes. We're flipping this board, so I want some alignment pin holes on this, and I'm going to just throw a quarter. I'm going to use a 1/4 inch dowel rod, wooden dowel rod, 1/4 inch dowel, or it could be steel. I got steel ones that I use, but we're going to throw a 1/4 inch one here and just one down here. They could be anywhere, you know, asymmetrical, whatever the case may be. They could be lined straight across. I kind of just do diagonal. It is what it is. And on the project board side, that toolpath is a drilling toolpath, and I usually go 3/8 of an inch because my dowel rods are a 1/2 inch long. I go 3/8 of an inch into the wood, the top piece, and I go 1/4 of an inch into the wasteboard, and my 1/2 inch rods, that gives me a little bit of play so I'm not bottoming out and everything. So this cut will be 3/8 of an inch. I'm going to be using a 1/4 inch end mill to drill those 2 holes. Actually, I don't want to change bits on this one. So I'm going to do it as a pocket toolpath with an undersized bit, my 1/8 inch bit. So 1/8 inch end mill, Pocket toolpath. It's not a drilling operation. Drilling operation is if I was using the same diameter bit as the hole. Since I'm using an undersized bit for a 1/4 inch hole, using an 1/8 inch bit, it's a pocket toolpath. So we will, with those two selected, that's going to be my alignment holes. Side 1. We good? All right. So let's look at something real quick. Speed Tool has the finest tip. Cool. Tapered ball nose. Yeah, they do. Really good. Why cut halfway and not all the way through on the flip side? Because if I am using tabs, if I cut all the way through and everything, there's a possibility that I'll lose my tabs, like when I milled away the surface, because tabs start at the bottom of the part, and I milled away the surface by 1/8 of an inch, and my tab is only either a 1/16 of an inch or 1/8 of an inch thick, so there won't be no tab. If I flip it over and I go to cut through, there's no tab there because that material is already gone. It's been surfaced off to create those pegs. I want my tabs to be in the middle of the part. So if I cut halfway through on one side with tabs, halfway through on the other side with tabs, then the tabs are at the bottom of the cut. They'll be in the middle of the part. That's why I cut halfway and half and half. Let's see here. Be careful, you are double-sided. I am double-sided, yes. Let's see here. I wouldn't cut them on the CNC personally. Pre-cut, pre-sized strips glued together on the ends, machine, then cut to length on the table saw. Hey, that's nothing wrong with that at all, Michael, for sure. Some people only have a CNC and they don't have other woodworking tools in their shop, so this just kind of shows them how to do it all on the CNC. But hey, whatever tool, the CNC is just another tool, just like a hammer and a nail gun and a table saw and a joiner and all that stuff. It's just another tool in the shop, and it's not the albeit answer to everything. It's not the go-to tool for everything, but it can do the jobs of a table saw, a miter saw, and many other tools and everything, a planer and things. That one CNC can do all that, a drill press and all that stuff. And it can do it very well and very efficiently. So if somebody doesn't have all those other tools, this just shows them how to do it on the CNC all as one. But if we have other tools that are faster and quicker and more, production type thing, then we would use those, right? So absolutely. The way you decide it, nothing wrong with that at all. It's a good point. And if you've got the tools to do it, great, do it. Because I'm probably the same way. I probably figure out what would be the more efficient way and long way to do it. But also, if I could do it on the CNC while I do other things and have these parts cut out for the kids or whatever, and yeah, that kind of thing. All right, so let's move those alignment holes up to the top, and so those will be cut into the there. Now, when we flip the board over, I'm flipping along the y-axis, right? So when we flip over to side 2, and Stephen, Calusa Custom Cabinets. Steven, did you understand what I mean? Why I do both sides? Because of the tabs, if we're tabbing, because we need the tabs in the middle. Tabs are formed at the bottom of the cut and up. So if it's an 1/8 inch tab, it starts from the bottom and it's an 1/8 inch up. That's how thick the tab is and that kind of thing. If I've already milled on that one side that 1/8 of an inch away, then there's no tab, no material, no wood for a tab there. And it won't create it. It's not going to create a tab somewhere else. So by doing it half and half, I'm putting the tab in the middle of the part. So let's see here. Yes, tabs start from the bottom of the cut up. Okay, how thick it is from the bottom of the part up. Yep. All right, so on side 2, we have all of our holes here. But first, before we flip to side 2, let's take our profile. Let's get back over to here. Back to side 1. We need our profile, And we need our inside rectangles, which I haven't selected yet. Notice those aren't selected yet. So let's get those selected and grouped together. Our inside rectangle, that's important for side 2. So let's select that. And that. Bear with me, I grabbed some circles when I shouldn't have. Let's grab that. Bear with me, almost there. Okay, so inside rectangles are selected. Make sure that's the only thing selected on here. And then G for group. Group. Awesome. Okay, so that we need, and our profile we need. Right click and copy to other side. All right, now let's flip over to the other side. Side 2 here. Cool beans. All right. Oops, I keep double clicking the single click to flip. Okay. Now we have a pocket cut that's going to cut the material away from in here. These pegs are going to be freestanding. Now, when I first did my parts and everything, these holes here, these circles are hollow, and it's because, you know, when they're injection molding and stuff like that, less material and things like that, you know, it's a way to save money. So they don't need to be hollow, right? It just needs to be these rings that are formed and everything in an actual Lego, right? Well, when making this, I have a choice, okay? Do I mill out these inner areas here, or do I just leave it as a peg, right? Because these are wooden building blocks and stuff, and they don't necessarily have to, you know, we don't have to necessarily mill them. Now, if we want to have that, you know, that authentic look where it is a hollow kind of tube, you know, kind of thing, we can go in there. And if you, let's go back to our side 1 for a moment. I don't know. I'm so sorry, guys. I shouldn't have drank a soda. But these inner circles here and these Legos, they're hollow. You know, they're hollow. It's just those little outer tubes that are created in the bottom of a Lego and stuff. And the question is do I need to waste the time to pocket those little things out, or just leave them little solid pegs, right? Because for me, I don't know. It's kind of a toss-up, and I'm not going to do it, but you could, right? So what I want to do is we have our holes here. Once again, since things are grouped together, I can now select everything like this, right? I can select everything like this, and then I can turn off what I don't want. So what I do want is the inside circles here and this, you know, as that. And if I did a pocket cut now with these all 3 vectors selected, it would pocket here and it would pocket here, creating that hollow tube, okay, that we're talking about. I am undecided if I want to do that or not. The first toolpath, we're going to create it with kind of the hollow tube. The second toolpath, maybe not, right? Okay, let's do it with it so we can have that nice little look at the end of the toolpath here. And then we'll do it without. I'll show you how to ungroup things. All right, so pocket toolpath. Now my pegs are 1/8 of an inch, remember. So what I want to do is I'm going to go, if we went by the blueprint, I mean, it goes almost, the whole inside is hollow again, removing material, less plastic, you know, it's a money thing, right? Less plastic. Well, this wood we're not gonna the offcut or the waste wood. There's not that much waste in there, right? So there's nothing we can do with it anyway. It's sawdust. We can make fire starters or something with it, but we don't need to go that deep. They go pretty deep where there's very little thin material at the top left. You know, it's kind of a deep pocket if you've ever seen a Lego. We're not going to go that deep. We're just going to go deeper than our pegs, right? So things fit together without bottoming out, right? So my pegs are 1/8 of an inch. I'm just going to go about 0.15 inches deep. So 0.15. Using an 1/8 inch end mill, we're going to calculate that toolpath and preview the visible toolpath. And we could go deeper, you know, you can go deeper if you want, but there's really no need to. And I'd like them to be a little bit sturdier, right? I'd like them to be a little bit heavier and sturdier and stuff for the kids, you know, durable and all, not fragile where they're going to break and everything like that. So I think just going just a little bit deeper than the actual pegs go is fine. Okay. All right. Let's, so we can actually see these guys and things. Let's create our profile toolpath. Profile toolpath, cutting 3/8 of an inch deep, 1/8 of an inch end mill outside of the cut. We're going to add our tabs, and they're already there. And we're going to calculate that cut. Preview that cut. Now we haven't talked about the alignment pegs on the waste boards yet. We're going to talk about those in just a minute. We still have those holes to drill and everything. But what I want you to look at here is I want you to look at the tabs, and I want you to see how they're in the middle of the part. Our 16th inch tab here and 16th inch tab here to create that 1/8 inch tab in the middle of the piece. Okay, so if we flip that over, you can see those tabs in the middle of the part. Okay, now what I want to do, because of just preview purposes and everything, I'm going to take the tabs out for just a moment. I'm going to take the tabs out for just a second and recalculate. We'll put them back here in just a moment. I want to flip back to side and preview that visible toolpath to cut those out. Want to flip back over. And calculate that. Oh, I just preset the preview. All right, preview those two toolpaths again really quickly. Right, throw them on the floor, check and step on them barefoot to check the durability. Absolutely. Oh yeah. That's every kid that had a Lego. I don't think Lincoln Logs. I don't think I ever had any worries stepping on Lincoln Logs. Legos were sharp. All right, let's flip over to the other side. Go into our profile toolpath and turn off the tabs for just for preview purposes, and then preview those toolpaths. So again, now this is our 8-piece just a few little design changes and adjustments and everything. We could have a 6-piece, a 4-piece, that kind of thing. You can have different sizes and all. So you can have some fun with it. Hopefully, now I'm going to double click on the waist here. All right, so if we look, these would be our Lego pieces, right? Fun stuff. Now, if you had tabs and all, you got a little bit of sanding and stuff to do, but hey, you know, but think of, you know, just different colors, you know, different species of wood and things, you know, pine and maple and walnut and whatever, you know, sapele and zebra wood and things like that. You can have some pretty cool little Lego blocks and stuff like that. And this board with the toolpaths and everything, if we look, rough estimate based on my machine, my tool, you know, speeds and feeds, that's different from other machines and things like that. You know, you're looking at roughly about an hour and 27 minutes of, you know, runtime or something to knock out, you know, these pieces and stuff. But let's talk about really quickly. We got to finish up on side 2. Our alignment holes, right? So we had our alignment holes. Let's turn off the toolpaths for a minute. We had our alignment holes from side 1. We need to copy those over to side 2. So copy to other side. And on side 2, we create the toolpath. Okay. We create the toolpath. And it's going to be a, again, undersized bit with an oversized cut, you know, hole, 1/4 inch hole, 1/8 inch bit. And this is going to go 1/4 inch deep, 1/8 inch end mill. And this would be our waist board alignment holes. Now, we're going to calculate this. Now, I need each of you to, that if you haven't done two-sided machining and stuff, understand this concept, okay? And I'm going to try to explain it to you. So we have our board, okay? We have our board, and we have our 2 alignment holes laid out for the top of the board for side 1, okay? Side 2 is going to be the side with the image on it. Side 1 is side 1. So our alignment holes are going to get drilled in 3 inches of a deep. They're going to get pocketed 3/8 of an inch deep. And when we flip that board over, so now this hole that is here and this hole that's here, when it flips over, because I'm flipping along the Y, now this hole is in the front here and this hole's in the back. If I was flipping left to right, then, you know, I'm no longer in the left corner, I'm in the right corner, that kind of thing. So you got to know how you're flipping. But when I copy those holes to the other side, it puts them right where they belong. So notice here, side 1, we got a hole here and hole here. But side 2, okay, let's flip that over. The hole is here and the hole is here. So the software flips that already for you. So I'm flipping along the Y-axis. Now, when side 1 completely gets carved, pocket cut, doing the peg formation and then cutting the parts halfway out, that board gets completely removed out of the way. Our X and Y is still the same. It hasn't changed at this point. We are going to zero out on the waist board at this point, zero out on the waist board, and then we're going to run the alignment holes toolpath for the waist board, and it's going to cut that 1/4 inch. Because our job is set up to touch off on the material surface in this case. So side 1, we're touching off on the board and we're drilling into the board. Side 2, which is the waist board, 0 is the top of the waist board. We are touching off on the waist board because consider that your material. You're drilling into it, that's the material. So 0 out on the top of the waist board and then do your holes. Once the holes are done, your board gets flipped over and placed, put your pegs in, pop it on there, clamp it down and all that stuff. Now it's perfectly aligned to that current X and Y. and we reset our Z back on the zero on the top of the surface. Retouch off your Z, and now you're carving back on top of the board. Some people, they will, since they have a 3/4 inch board, they move it out of the way. They might zero off on that board before they move it, and then they'll just drill. They'll make their tool path 3/4 plus 1/4 of an inch. You know, so 1 inch deep. So it just starts from the air, and it comes down in pockets down to the wasteboard. It's a waste of time. It's just carving that air. It's a waste of time. Move the board out of the way. Zero out on the wasteboard. Cut the alignment holes for the wasteboard. Put your board on there, get it on the pegs, get it all clamped down, and then re-zero out on the top of the board to cut side 2. Do y'all understand that? I need you to understand that. Okay. And David said, hold on a second. The circles on side B shouldn't be connected, should they? The last comment was not correct. Hey, thanks, Brooke. Appreciate you. Thank you, Brooks. Really appreciate that. The circles on side B... The circles on side B shouldn't be connected. That last comment was not correct. So I think, are you saying that your question wasn't correct? Thanks for the thumbs up, Crystal. David, start over again. And if it is a question, put it back in. If it's not, let me know. Oh, no, it was a mistake. Okay. So, side 1, the alignment holes get carved in the top of the board. All the tool paths for side 1 get carved, and then that board gets moved out of the way. We zero out on the wasteboard. We run the alignment holes for the wasteboard to cut our 1/4 inch holes. And then we flip our board over and stick it on those pegs. Got our 1/2 inch long dowels, 1/4 inch in diameter in our wasteboard. We stick it on our board, press it down, clamp it down, and then we run all the tool paths for side 2. Zero out your Z on the top of the material, run all the tool paths for side 2, right? So that's how we do a 2-sided job. Okay, cool beans. All right, and the holes placement, the hole placement is based on the current XY at the time. And the reason why we do half the holes in the board and then the holes on the wasteboard is, let's say that we were carving side 1, right? We had some downtime. We were making some Lego blocks and everything, and we got side 1 all done. But then, oh, hey, it's back to business. Call comes in, emergency job needs to get done. We got to get on it right now. We don't have time to carve side 2 for now, so we've got to move on, get our new piece of material on, zero out X and Y, and run this project that just got ordered, right? That scenario. Well, when that order is all done and everything, and I do have downtime again, and I want to get back to carving my parts, my side 2, wherever my machine is zeroed out at that point in time, all I have to do is run the alignment holes for the wasteboard, zero out on the wasteboard, and run the alignment holes. I can take my board from last week, put it on those pegs, and I can carve side 2, and it'll be perfectly aligned. Because it's not, if I drilled all the way through my material and into my wasteboard, then those holes in my wasteboard would be based on that current XY, meaning I got to finish the job, it's got to get done or else I'm going to lose my alignment. But by drilling halfway in the board, halfway in the wasteboard, I can drill that wasteboard anywhere on my table. I can drill my 2 holes, flip my board over and press them on those 2 holes, and it's all based off that current X and Y. Do you guys and girls understand that? If you do, give me a thumbs up. So if we weren't able to finish, that's why this is a great method. If we weren't able to finish, we could come back to it and still be good to go. Zero out our machine wherever we want to zero out our XY, touch off our Z on the wasteboard, drill the holes, flip the board over, put it on there, and everything works from that current XY, and it's all lined up. So, all right. Okay, so this project is done. So now, right, we've got our board pieces, and again, We could come in just for scenario's sake. Let's go back to side 1. Let's go back to side 1. Let's go back to sheet 1. Wait for it. And if I wanted a 6-piece peg hole, I could come in here. I'm going to make a copy, even though that is a copy. Remember, my original is still intact on another layer, right? But I'm going to hold the control key down and drag a copy over. And I'm going to come in and I'm going to eliminate those 3 items. Okay, now I've got a 6-pegger, right? And remember, from the center of the hole to this outside edge, remember it's that 0.2321, which is that 0.393 millimeters, right? So all I have to do is take a guideline, snap to the center of this circle, right click on the guideline, and create a relative guide. Let's go back to our blueprint. Just so you know, I want you to work off the blueprint and all. Remember, from the center of the hole to the outside edge is 3.93 millimeters, right? So let me get down here. If I right click on here, relative guide, 3.93 times the letter I equals, and then click create new guide. Okay, all good. Why does that? Give me just a second. That doesn't look right. Let me delete that. .93, not 0.393. 3.93, ladies and gentlemen. Let's try that one more time. Relative guide. 3.93 times I equals. Click create. Still looks. Oh, this one's scaled up. This one's scaled up. Hold on. This one is scaled up. I'm sitting there going, that doesn't look right. Remember, we gotta think. Gotta think, Laney. You're not thinking, Laney. Somebody's probably yelling, hey, you're working on the scaled one. You're working on the scaled one. So let's go back in here and let's come here for a minute and turn on our master block. Right? Let's take our master block. Sorry. Control C, Control V, and drag a copy up here on the board. And then move that to another layer. And turn our master block back off, right? All right, one more time. Let's not screw this one up. Get rid of these 3 holes. Come in here with our guideline. Right click, relative guide, 3.93 times I equals, create guide. Beautiful. That looks much better. And now I can take these and I can go into node editing, keeping their spacing. I'm going to select all these nodes and I'm just going to use my left arrow key. And let's zoom in. Let's get right on it. Okay. And so now we have a 6-piece. And remember, this could be a master copy. Oops, get out of node editing mode. This could be a master copy for your 6-piece. So we could take and Control C, Control V to make a copy of it. Take this and move it back to the master layer. Move to layer and go back to that master block layer. So now we got, the 2. and then scale this one up. Remember, we went 150%. So size, percentage, 150. Scale that up. And now we are, back to here, right? On our scale for our blocks. So now we have a 6-piece. And then we could do that for a 4-piece. And so on and so forth. Right? Cool beans. All right. Yes, JR, you just have to do it and then it'll click. It'll make sense. So hopefully you guys get that concept. Use your master, right? And then you can make your 4-piece, your 6 pieces and all that stuff. And yeah. So this one here, this should have been our this should have been our 6-piece, which is this one here. And then this is our 8-piece and our 6-piece. So I was trying to, what was confusing just a few seconds ago is I was trying to use the blueprints, distance and everything on a scaled object, right? That we had already scaled up 50 times its size. I could have done the math and made it happen, but work off the master, right? That's what it's there for, that kind of thing. Okay, so as long as you understand that, good. Let's go. Now, the last part of the class, guys and girls, we're going to make some furniture. We're going to go big, but it's not like what you think it's going to be when it comes to making these Lego parts. And it's going to be pretty straightforward, but I want to see if you get it, right? So it won't take long. It's not going to take long to lay out the parts, but let's hit save on this. And again, these blocks can be sized up. They can be scaled up to whatever size you want, right? Just make sure your thickness is accommodating, right? You know, if you got a big block, you want a little bit thicker, you know, for kids to play with, you know, toddlers and stuff like that. But go on that. Rodney says, do you have a clearance number you like to use to get the parts to fit better? Yes, to fit better. So that brings me back to our toxin stuff. Side 1 on these parts. Let's go back to side 1 here, which is sheet 2. Side 1, you know, when we did all of our peg formation. Okay. On the pocket cut on the back side, side 2, where we cut the pocket out and everything, no allowance offset. It's going to cut to its regular shape, its regular size. So when we do the pocket cut in here and everything, no allowance offset. We want to just cut that pocket and everything. It's the pegs here that we want to overcut, if you will, to make them slightly undersized for that good fit. Right now, as it stands, the peg formation toolpath has no allowance. Okay, so it's almost like an inlay, right? Getting two parts to fit together. For me, because you got to remember, you're taking material off of two sides, right? So off of both sides and everything, and then the top and bottom. You're taking material off all the way around. So if I'm taking 2/1000 of an inch over here, I'm taking 2/1000 of an inch over here as well too, right? You know, for 4/1000 of an inch. So you really want, you know, I want a nice snug fit. I want the parts to be able to snap together, but also at the same time, and don't ever use MDF for these, guys and girls. Don't use MDF, because when those parts get stuck together, when you go to pull them apart, the little pegs will just rip right off, because they're paper, compressed and glued paper, right? Kind of fibers, not paper, but you know, so don't use MDF. But I want a nice pressure fit that's easy to snap together, that holds, but I don't have to beat them together, right? So for me, my pocket allowance generally, especially like with inlays and stuff, it's always a negative number. We're cutting over the line, okay? So we want the bit to go over this line a small amount. So it's always a negative number. A positive number is away from the line. Negative number is over the line. Okay? Always remember that. But I usually go a 0.002 as my allowance offset. That's kind of my first go-to. Okay, that's my first go-to overcut and everything. It really depends on the fit and what I'm looking for and stuff, but that's kind of my go-to. If that's still too tight, then I'll creep up to like a 0.005. So I'll go 0.003, 0.004. I'm going to sneak up to that perfect fit. That's what, testing is all about and stuff. Always cut your male parts. In this case, the backside, when you cut them, it's hard to fit because they're on the same side of the piece, right? So this is where you have testing. So always cut the backside and then cut your front side, because then you can adjust that to the perfect fit. But if you're doing, your practice pieces, like just a few pieces and all. But my go-to number is always 0.002. 2,000ths of an inch, and then from there I'll sneak up to what I have. I very rarely ever go any more than 10,000ths of an inch, right? So I very rarely have to get up that high and stuff. It just depends on the circumstances and stuff. That's my go-to. Can you give those tool info again? I'm at a spot where I can write it down. Big Daddy, what tool information? The bit tool, like the speed tool? The speed tool? Is that the one you're talking about? The 1/8 inch upcut spiral end mill SPETOOL, 1/4 inch shank, 1 inch cutting diameter. It's called the extra long length speed tool from Amazon. Is that what you're talking about when you say the tool info? SPETOOL, 1/8 inch on Amazon, 1/8 inch upcut, downcut, compression cut. They have it all. In this case, it's an upcut, 1 inch cutting fluke, 1/4 inch shank. Is that what you're asking for? Yes. Okay, good. Yeah, Calusa cabinets, HDPE, also referred to as starboard or kingboard or things like that. High density polyethylene is great. Also, another form of that is UHMW, ultra high molecular weight composite plastics. Those would be great for that too as well, for sure. Yep. And they have different colors, black and white and things like that. Different colors and all. So, yes, my peg formation toolpath would have an allowance offset slightly overcutting those pegs, so they're slightly smaller than the backside pocket areas, so I get that nice friction fit. If I don't give myself some kind of an allowance, then it's going to be beating those parts together, right? It's going to be some kind of allowance, but don't go too big right out of the gate. Sneak up on that perfect fit and then stay consistent with it. Okay. Big Daddy, did that answer your question? Speed Tool, SPETOOL on Amazon. This is called the extra long 1/8 inch diameter upcut spiral bit, 2 flute, 1/4 inch shank. And to be honest with you, if you on Amazon in the search bar, if you literally typed in 1/8 inch router bit, 1/4 inch shank, Speed Tool would be kind of one of the first tools that comes up. It's the extra long length one. Okay. So let's move on to really quickly, because it's 9 o'clock. I want to wrap up. Everybody's getting asleep, falling asleep, and all that good stuff and everything. Wake up, because this is going to be the cool part. We are going to make some furniture, a little cabinet, cabinet. But the way it's going to be made, you wouldn't think that that's the way it's going to be made. Because you would think it would be something like what we're just doing here, but it's not. But it's still going to look like a Lego when it's done. All right, let's go ahead and save this. And let's go ahead and close out of that. And I'll make these files available to you guys. I'll clean them up and I will make it available as a digital download for y'all and for something to play with. But fun stuff. Hey, it's almost Christmas time. Maybe make some, and if you do make some, share photos with me. I'd love to see them. Okay, we're going to create a new file. Now, these cabinets, just so you know, let's get over here. These cabinets have an overall height, not counting the pegs, we'll talk about the pegs in a minute, but an overall height of 4 3/4 inches tall. Okay. 26 5/16 inches in length. 6 3/16 inches in width. Okay. All right. And now with the pegs, top to bottom or bottom to top, we are the pegs themselves. It's about 6 inches tall. Let me see here. Oh, let me work with me. Yeah. The pegs are 3/4 of an inch tall. So 4 3/4 plus another 3/4 is 5.5, right? Okay. 5.5 inches over tall. So not that big of a drawers, little caddy type drawers, and they are stackable. They stack together and you can create all kinds of neat little things. And these are they kind of mimic the 8-piece that we have, right? So let's I'm going to go back into Vectric. Now I'm going to go 20, I'm going to go 30 inches wide. And I'm going to go 11 1/4 inches, like a 1x12. Okay. 3/4 inches thick. And of course, the thickness of your material, you can make it any thickness you want. 3/8 if you prefer like a 3/8 cabinet, you know, a little bit lighter weight than 3/4 and all that. Don't go any bigger. So 3/4 or smaller, 1/2 inch, 3/8 kind of thing like that. I probably would, it just depends, right? So I'm going to go 3/4 on this. Now, did you know that if you have SketchUp, which is, you know, a program that you can draw and do 3D design in and stuff. So this is my SketchUp here, and it's version 8. jayscustomcreations.com, Jays, jayscustomcreations.com. He has a SketchUp page and he has a download link for the free version, I believe he still does, of SketchUp, and it's a great program, and he has tons of tutorials that you can learn SketchUp very fast to draw and model and stuff with. But a SketchUp file can actually be imported into Vectric, right? So let's do that. Import a vector, and we're going to open up our Lego drawer. Now it's going to open up the SketchUp file import window. And on that import window, we're going to do an exploded flat view because the parts are going to be flat. We're going to auto-orientate them largest face up, or we could orientate them by material color. Like if we actually painted the material and everything, we could do that, you know, and stuff. But I'm going to auto-orientate, right? We are going to, it doesn't matter because I'm going to be laying the parts out differently. So just 1 inch between each part is fine. I want to create circles for polygons, and I want to try to refit arcs where I can, you know, because SketchUp doesn't have the best looking circles and things like that. Grouped objects, those objects that, you know, like the walls and the drawers, they're grouped together. I want to import those parts, and it'll lay them out individually. And I want to try to keep them together and stuff. And I could replace the outer boundary, you know, for flat, you know, jobs only. But I'm going to leave that unchecked. Now, it says here I have 95 parts, which I do because I have all those cabinets and everything like that and all. But I could, you know, import them by import them by visible data on selected layers. right? And in this case, they're all 95 parts are on, layer 0, right? Or I could import the data, all the data in the file, which is the same thing. And in this case, what I'm going to do is I'm going to leave this like this just for a second. And I'm going to go back into my SketchUp for just a second. Hold on a minute. It's trying to open the hold on a second. It's trying to open my SketchUp file in Vectric. Don't do that. I want to open up in SketchUp. All right, what I'm going to do is I'm going to take one of these drawers, because I only need one. I'm going to take one of these assemblies. Okay, doesn't matter which one, just one of them. And I'm going to I'm going to move them to another layer, right? So the entity info. I'm going to put that on window, layers, add a new layer. All right, one more time. Entity info, put that on layer 1. All right, and now save that, file save. Wonderful, wonderful. And I just want to import what's on layer 1, okay? So flat layout, auto orientate, create circles, refit arcs. I just don't want this, and click open. Okay, so here are all my parts. Okay, these are all my parts for that box. So I want to move them to the side because I'm also going to show you how to make this, how I design this using our master, right? Using our master and everything, because this is, somewhat to scale and all that good stuff. But we could take our master. Let's go open that back up real quick so I can grab a copy of it. Name that tune. All right, let's go into our master block layer. Let's grab, make the board active. Grab the block and copy it, right? And I'm going to go into my other window and paste it, right? So just a simple copy and paste. And then I can close that design. Don't need it open. Okay, so I just want to copy that just to grab that in there. Now, this part, if we look, if we select here, this part is, it's got a 12.4 inches by 6.19 inches, that's how wide and how long it is and stuff. And I could take my master part and kind of get it, to that scale as well too, or that close. But let's size this up. And this time I am going to use inches. So it's going to be 12.44. Okay. And that could be the start of my part as well too. Now, here's what you got to understand, okay? We have, and I'm going to show you this in steps and phases here. Let me get rid of some things so it's not so confusing. Let me turn this around and let me select this and hide it. Let me select this and hide it. Okay. Let's go in and pull the drawer out. Okay. And let's start to dissect this. So let's make an exploded view here. You guys still with me? Good. Move this out. Take our, hold down our shift key and select these and move them up. Zoom out. Take our top lid and move that up. Come over here, take our side piece and move it out. I'm just kind of exploding the view, if you will. Our back piece, move that out. And then our bottom piece, and then our drawer, let's do that really quickly. The front piece, let's explode that. Explode. Move that out. Move that out. Move this out. Oops. And then we'll move this one over. Okay, so a lot of this stuff can be done on a table saw, right? A lot of this stuff can be done on a table saw because you're just cutting, boards down to size, and you're cutting a rabbet cut, for assembly, right? And some people might like their drawers and stuff to not be so bulky. Now, all these boards on here are 3/4 of an inch thick, for the drawer and all that. You might want a 3/8 inch drawer, 1/2 inch drawer, size it appropriately, to fit into your cabinet, whatever you want to do. I went with 3/4, right? Now, very easily, I could take these, pieces of material, panels and things, and I could take them over to the table saw and cut little rabbets and stuff in them. I could put a dado blade in or do it with a single blade, whatever the case may be. But I'm going to lay these parts on a CNC, and I'm just going to pocket cut these rabbets and everything on these pieces of material, right? Again, this is in the assumption that there's other tools that do this job. I could take a router table and run the parts with a router bit, right, to cut my rabbets and things. If you've got the tools, use them. But in this scenario, we're using a CNC, okay? Give me just a second here. Michael Keymont says, if you want to avoid using tabs, we talked about tabs and two-sided tape and all that stuff in there, we could do an onion skin cutout, leaving a few thousandths of an inch left, and then do a cleanup and stuff on that. So that works really well. Let's see here. PVC trim board would work great also when we were talking about the parts and stuff. And thanks, Brooks, for everything. If you're still there, if you haven't left quite yet, thank you. Thank you for using the super chat and the donations. Those are awesome. Thank you. And Inspector Gadget. Michael was on it. He heard it. Love this idea. And banks and jewelry boxes and things like that. And my little boy Michael loves his Legos. This is such a great idea. We'll have to make one. Good. So cool. All those. I just wanted to catch up on those comments, and all you guys were able to read them. I didn't have to read them out loud, but I wanted to be part of the conversation. Thank you for that. Okay. So all of you understand that these parts could be made on other machines. A router table, table saw. There's no question about that, right? We're working under the assumption that we don't have those tools. We just have a CNC. So how would we make them on a CNC? That's what we're doing here. So we have the parts for the jaw, okay, that we're going to be working with, the parts for the jaw, and then we have the parts for the Legos. Now, notice that these parts, the pegs, are not actually part of the board. We will be cutting out these pegs, and some people put Lego, the word Lego engraved on the top, or whatever the case may be. That's fine. But we will be cutting out these circles out of a board. They will have a center hole drilled into them. We're going to be creating that toolpath and all for a dowel. And our top panel will also have dowel holes in it so that we can glue these round pegs to the top of our board. That way we don't have to have a 3-inch thick board to create this top piece, right? So I want to pull up an actual image of one of these kind of concept pieces and things like that. And let's use this. Bear with me just a second. All right, let me pull up an image. Okay, and let's see, we can zoom in here. Okay, so this is one of those cabinets, right? So they've got the sides of the drawers are made out of plywood. You can see that, right? Then they used hardwood for the outer cabinets. And notice that hardwood is probably only about 1/2 inch thick, right? Not a full 3/4 kind of thing. Only about 1/2 inch thick and all. But these parts here, these pegs that they have the word Lego V carved in and all that stuff, these are cut out. Notice the grain, okay? Notice the grain on these pegs versus the grain on the board. They are separate. It's not one board where these were pocketed and cut out of this board, right? They are attached, they're glued to this top panel to create that Lego look. So when we cut out these, most likely you can see the grain, right? So 90% of the time, I can almost guarantee you on this particular one, they had a long round stock of a piece of material that they cut these wedges out of, right? So long round stock that they cut these wedges out of, because you can see the end grain is on the top and the edges and everything, right? For us, we're going to take a board and we're going to cut out these circles out of a board. A 1.5 inch thick board, a 3/4 inch thick board, whatever, 1 inch thick board, that's up to you, however tall you want your pegs to be, right? I'll show you how tall they are in the drawer. So these are cut out of a separate board. We will be putting a center hole in them with it so we can use a dowel stock, and we will be putting a center hole on our top panel of our cabinet here so we can glue so they fit right in, so everything gets aligned and spaced perfectly, and also we don't have to worry about them sliding around when we're gluing and clamping and all that stuff. But that's how our top board is going to be made. It's going to be made with these separate things glued or attached to the top, right? And then notice here, if we look very closely and all, they just did butt joints here. There's no rabbets or anything like that. They just did a simple butt joint where the bottom piece of material butted up to the inside of the side piece and the top piece butted up to the top part of the side piece, right? That's the way they assembled their box and everything. We're going to use some rabbet joinery and stuff like that. And then, of course, they used a plywood carcass for the drawer. You can see that plywood layers right here. And then a hardwood front piece, right? Nice little cutout, blah, 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 right? So the key thing is, and believe it or not, on the bottom side of this drawer, there is little openings that they can fit together. They can actually stack together in things where it would look like, let me see if I can pull this up. Where they can actually stack on top of each other, right? So there is a void or a space on the bottom so the parts can, fit together. Now, do the parts, I don't own one of those drawers. I never bought one of those drawers or anything like that, but do the parts, do they just sit on top of each other or do they actually link together like Legos? Ours are going to link together like Legos. Okay, right? So I just wanted to kind of give you that concept, right? So now that you got it, now that you have a little bit of an understanding of what we're going to do, hopefully this will make sense when we actually lay it out. And we're going to lay it out as quickly as possible. But let's go over here to our Vectric software where we have either our master or we have all of our parts laid out for the drawer. Either one, we could work from either or, okay? This cabinet, again, just as you know, we'll measure here. Well, I don't have to do that here. I can do it over here in Vectric. The cabinets, the side cabinets and everything here, they are, let me close this tool and go back into normal selection mode here. They are 4 inches tall, our side walls, 4 inches tall by 6.1968 inches in length. You could, that was just the math because everything was based on the spacing of the holes on the top, right? Everything was laid out from there. So basically, this was our top piece. Imagine, if you will, let's get rid of, just for the moment, let's get rid of this. And this is our master, right? So let's set those aside for a minute. This is our top of our drawer. Now, being scaled up, okay, that spacing, everything was based off of it, with our 3/4 inch material and all that stuff and all. So that's what we kind of have laid out here. And this opening, imagine, now what I did was if we measure from here to here, 3/4 of an inch, right? It's supposed to be 3/4. I overshot it a little bit, but imagine this piece right here is our bottom piece of our material. We're going to use our master versus these pieces that are laid out. Let's get this one on the board first. Let's get this on the board first, okay? And the top and the bottom have to be the same size, right? So what I mean by that is this inner pocket is used, it's going to be used for creating the pocket, but we need all of this. The top and the bottom are the same size. It's not like, shrunk in and all. So we're going to take these three and these two, holding that shift key down. If I hold the control key down, I can move a copy off, right? And then over here, I don't need those over here. So top, bottom. With me? With me. Okay, good. Now, on the bottom piece of material, our cabinet, we don't need the inner holes. So ungroup, 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 and get rid of these center holes. Delete, delete, delete. They don't need to be there. Okay? Now, what I did is I took a rectangle, and at the center, I drew a 3/4 inch rectangle all the way across. So we're going to go 3/4 of an inch, 0.75. Okay. And then I took a 3/4 inch rectangle this way. And it didn't have to be 3/4, but that's just the number I went with, right? Okay. Now, this rectangle is going to be centered to this rectangle. Align center up and down to that selection. All right, Michael. Great. You can watch this video later. It'll be there, you know, with that you can watch and stuff. And we want to align to center. Okay. This rectangle is going to align to the center of this circle. So align to center. Right? Right. Okay. Now, technically, the center of this rectangle, I can now hold the control key down and just snap it to the center of that circle and snap it to the center of that circle. Right? I could have done that. But I just wanted to show you how to use the alignment tool. Now, our bottom piece, if we look at here, so let's turn this over. So our bottom piece, oops, is going to have pocket cuts, right? That's where our pegs are going to fit and all that stuff. And it's also, turn it up, turn it up, turn it up. Let's come in here. It's also going to have rabbets on all three sides. So a pocket cut and then a rabbet on all three sides, right? So let's go back to here. And first things first, we need the vectors for the pockets. So the vectors for the pocket are, you know, we got to create them. Okay. So what we're going to do is we're going to use our scissors. What I'm going to do on each one of these first, bear with me, double click, select them, double click, hold down that shift key, pull just past the line. So when we trim, it trims easier. Holding that shift key does it on both sides. This one, hold down that shift key, pull it out a little bit, and it'll pull it out on both sides. Because we're going to use our scissors, and we're going to trim to connect that frame together, right? And then it's going to trim all the inside stuff in here, and I can just hold down my left mouse button and just move around, right? But all that inside stuff is getting milled away. Okay? Trim. Okay? All right. Hold down that left mouse button. In versions, I think 9.5 and up allow you to do this, but hold down that left mouse button and whatever your mouse touches, it'll trim it, right? So I want to trim all this inside stuff away and then even out there and out there. Okay, cool. Hold down, circle, trim, get in there, trim that away, and that away, trim that away up there, that away up there, and I'm just holding down the left mouse button. Whatever my mouse touches, it trims. I could click, and all that too, but that is going to be my bottom piece. Now, each one of these individual pockets are going to be what gets pocketed out in the pocket toolpath. So let's come over here. And let's get this on the board. Now, what's our board going to be made out of, right? So, like I said, I went 30 inches by 11 1/4, simple 1x12, because I can get my top and bottom pieces out of it, and I think I can even get my side pieces. We'll find out. So. Let's move that down. And I don't mind if I'm right on the edge. I don't mind if I'm on the edge, where it's cutting out that edge and all. If I want a machined edge, then I would back off the edge a little bit, right? Either way, your call. Okay. Now, very important. Let's get this on the board. Okay. Pick a spot, any spot, doesn't matter to me. Get this on the board. Now, I need a center hole in here. Okay, so I'm going to go 1/4 inch dowel. 1/4 inch dowel is all I'm going to use. You can go 3/8, you can go whatever, right? I'm going to go with a 1/4 inch dowel. And I'm literally, you type in 1/4 inch over here, diameter, and wherever your mouse clicks is where the center of that object you're drawing is going to land, right? So I'm going to snap to the center of the circle. When I get that crosshair with a little dot in it, that's the center. And I'm just going to left click. Move to this one, get to the center, left click. Get to the center, left click. Snap. Make sure you have smart snapping and geometry snapping turned on, and it'll make your life easier. Get to that center. When you see that crosshair with that little dot in the middle, that's your center mark. Just click. So now I've got my dowel holes. That's going to be, not only is it going to be the toolpath for the circles, but it's also going to be the toolpath for the holes on the top of my drawer piece, or my cabinet piece. You guys with me? Y'all good to go with this? Cool. If you got to go, understand, the videos will be here, but we're trying to get through this quickly. All right, now I want to, on my circles, okay, very important. Here's a little trick, fun little trick. I'm going to hit Control C to copy. Now, not only does it copy the circles, but it also copies their current position. Okay? Their current position. So that when I take these guys and I hold down my control, or double click on them, not hold down my control key, but when I move these out of the way, I'm going to move them up here for right now. Doesn't matter where, I'm just moving them out of the way. When I hit Control V for paste, or I could go over here and hit paste, or I could right click on the screen and hit paste, whatever floats your boat on any of those choices. I'm going to do Control V. When I hit Control V, it's going to paste those circles back to their current position where I copied them, right? So there they are. So I copied them in place, moved the originals out of the way because they're going to be the center holes for the circles that we're cutting for the dowels, right? Then when I hit paste, it pastes those back into their original position where they were copied from. We good to go there? You got that? Cool. All right. So my lid here, profile cut is going to be cutting it out, but there's also going to be rabbit cuts, right? Rabbit cuts. So if we know on the bottom piece, I told you that we're going to have rabbit cuts on all three sides and that kind of stuff and everything. Have rabbit cuts. So if we go and look here, all right, on these parts and everything, if I measure our parts, like I said, they're in this case the sides are 3/8 of an inch. It could be 3/4, 3/8, whatever you want, and everything. Normally cabinets, you know, they're lighter weight and stuff like that. That picture, not that picture, the other picture. This cabinet here. Okay, so kind of basing it kind of somewhat off that 3/8 of an inch sides and stuff. I don't know what keeps happening to that photo, but it keeps disappearing. Okay, so anyhow, those are, you know, it's about roughly about 3/8 thick material, and again, surface it down, plate it down, whatever you want to do, or go with 3/4, right? Just make sure that the parts are appropriate. If I'm going 3/4, okay, if I'm going 3/4 of an inch here, then I need to make sure that my box, my board, is big enough to accommodate from the edge 3/4 in for this piece to fit into that rabbit without compromising my edges to where these pocket cuts are going to happen. You know what I mean? So, and these parts here are the top and the bottom of my lid are 3/4 of an inch thick. It's only my side pieces that are 3/8. The two side pieces and the back piece is also 3/8 and stuff. But again, you can go 3/4. You just make sure you size it up appropriately. So in here, I'm going to draw a rectangle because the top piece gets a rabbit on all three sides, the left side, back, and the front side, and so does the bottom piece. Y'all with me? Everybody with me? People are still watching? Cool. All right. And again, bear with me just a second here. Brooks Martin, I think you left and all. Calusa Cabinets, thank you for everything. Appreciate you. For the super chats. All that little bit helps me buy wood and helps the channel and all that stuff. So thank you very much. All right, guys, here we go. Rectangle. Draw a 3/8 inch rectangle. Okay. It's going to be 0.375. 0.375. And click apply. Let's bring this down. Now, when our router bit comes and cuts this pocket cut, right? When the router bit comes and cuts this pocket cut, we want a nice clean edge. So first, get your 3/8 of an inch. Get your 3/8 of an inch part laid out. Draw the 3/8 of an inch rectangle. Get it laid out into position, right? And then on the outside, we can grab when we double click on it and put it in transform mode. We can grab this little box and pull it out past the edge. Remember, this is our profile. This is our edge, right? So we want the router bit to be able to cut past that edge just a small amount to create a nice, clean edge cut, a rabbet cut, you know? So just pull it out. We only need to pull it out this way. We do not pull it out too much on the front and the back. Again, just a small amount. So on our rectangle, hold the shift key, and pull out just a little bit here. Okay, just a little bit there. And it'll do the same thing on the back if you hold the shift key. So when it cuts that pocket, it'll create that rabbet. Now, same thing, 3/8 of an inch, because that's what my parts are. 3/8. If I'm going 3/4, guys, remember, then I need to make my outer perimeter wider. This isn't the Lego now. This is our dresser drawer. I need to make it wider to accommodate the 3/4 inch sides and the 3/4 inch back, right? Right now, I have enough for a 3/8 of an inch and still have, you know, material meat there, you know, and everything. So here, 0.375. And then when we have that 3/8 of an inch, snap it where it belongs, and then pull it out just a little bit past the border line, not much, and then hold the shift key. In this case, I'm going to go on this side. Hold the shift key, pull it out past the border line. So we create that. Okay. We're almost there. Now, I'm going to cheat a little bit. I'm going to draw a line down the center of my part, a straight line, just so I can take this part here on the right, select it, hold down the shift key, select that line, and then I can mirror it by flipping it about the line to the other side. Okay. Now, if I wanted to, since this is going to be one big pocket, right? I don't have to have 3 separate rectangles. I could trim, thank you, Stephen, I appreciate it. I could trim those lines together. I could trim those lines together to create just one uniform pocket. What I mean by that is get rid of that center line. We don't need it anymore. But what I mean by that is make sure you don't accidentally trim your border line away. Don't do that. But here, okay, on these pocket vectors, sorry, getting tongue-tied there. I can trim. Remember, don't accidentally trim your border line. Okay, so that pocket there, come over here, trim, trim, trim. Okay, and what I've just done is this vector right here, I just connected those 3 vectors together. That's all I did. So that when I do my pocket toolpath, it just cuts all that out, right? Right? Cool. Cool beans? Good to go? All right, cool. So that's that one. Now, technically, This board, top board, bottom board, same size boards, right? Same 3/8 of an inch pocket is needed, right? Why draw what you can copy, right? Now, remember, from my profile line to the inside line is 3/8 of an inch. Let's verify that just so you can see. So horizontal from my profile line to my inside vector of my pocket is 3 point... Give me a second. 0.374. How did I get 0.374 when it should be 3/8? What did I do wrong? Let's measure the top. Let's see if I got 3/8. Let's see if I accidentally moved. That's 3/8 on my side. And of course I mirrored this one over, right? So what does that mean for me? Don't you hate when you're like on a flow and then things go wrong because you're off by 1/1000th of an inch? Holy cow. So quickly fix, Control Z. Okay, come back over here. Make darn sure that my part is 3/8 of an inch over, right? So once again, I'm going to just make sure my rectangle is the right size here, and I'm going to make sure it's 3/8 of an inch. So 3/8 of an inch wide, size tool. I'm going to uncheck this because I just want to change the width and make it 0.375. Okay. Now zoom your butt into the part. Zoom, double click on it. Find the middle part right here. Zoom, 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 and drag that line over and snap it to your profile line. That puts this where it's supposed to be. Okay. So make sure you are snapped right on that profile line. From there, now I can drag this side. Since this is positioned, I can drag this out. I'm just going to go out to there. And then let's verify, right? Let's verify that I'm still 3/8 of an inch. So if I measure horizontally from my profile line to my inside line, 0.375. There we go. Don't accidentally move it. All right, one more time. Select this, select our center line, and mirror by flipping over the line. Okay. Take our scissors and let's do some trimming. Trim, 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 and trim. My profile line needs to stay intact, okay? I'm only trimming these rectangles together here. So it creates that profile. Okay, now let's get back to the point at hand. Remember, these two objects are the same size. Don't need that center line anymore. I can take this object here and I can select it. I can select this object, which is my border, and I can align to the center of that selection, right? But that just moves my part, remember? So I need to copy first. Control C, right? Control C, just Control C for right now. Now I'm going to move my part, and then I'm going to hit Control V, right? Close this tool, and then hit Control V to put that part back, right? Remember, I copied it. It's an original position. So over here, right, because we centered and everything, let's make sure what's critical is back here. Let's make sure that we are 3/8 of an inch in. The sides should be, but vertically back here, this is the important part. From here to here, I'm not at 3/8, right? I got to get that to 3/8. I knew I had to shift that up and down. That's fine, because remember, it centered it, and these parts were longer, Okay, that's going to happen. The critical part is this right here, horizontally, from my profile line to here, I should be at 3/8, which I am. Good to go, right? So this one, I'm at 0.394. Okay, now here's something for you guys and girls, a little bit of math and stuff. Move tool. I am moving relative to its current, from its current position, relative movement, and I'm moving up in the Y. It's a positive number. Currently, right now, I am sitting at 0.394. So if I type in 0.394 and I subtract what I want to be at, which is 0.375, so minus 0.375, and I hit equals, the answer is the distance I need to move up. So when I click apply, it's going to shift that up, that distance, that difference, right? That difference. And now if I measure from my profile to that inside line, I'm at 375, right? So I was at 394. I want to subtract what I want to get to 375, and that distance that's remaining, that remainder, that's what I actually need to move up to get to there, right? Cool stuff. All right. Okay, so now I've got my vectors for my pockets, for my rabbit cuts, for the top and bottom lid. Hell, we're 90% done, right? Now, my circle holes that are getting cut out of the material and all, I'm probably only going to carve them out of the 3/4 inch material that my top and bottom are getting cut out of as well. So I'm going to use the same board if I can, right? So first things first, I want to ungroup these circles so they're all individual. And then I want to group the individual circles and their center hole. I want to group them individually. So select G for group, select G for group. Do each one of those one by one. G for group, G for group. Okay, cool. Now, I can now move these around and try to minimize my waste, right? And put them, you know, where I want to put them and stuff to see if they can fit and all that stuff and everything. Well, I'm going to nest them. If I have Vectric VCarve Desktop, or if I have, thanks Ronnie, have a great night. If I have Vectric VCarve Desktop, I don't have the nesting tool, but if I have Pro or Aspire, I have the nesting tool. And when I'm nesting parts, I can nest inside of a selected vector, a boundary layer or what have you, right? Okay, my nesting boundary. Used bounds layer, right? I can pick a boundary by using something on a layer. What I mean by that is I'm going to get this part. Let's get this part here into position. I'm going to bring it down closer to my edge, not right at my edge, but just closer. Okay, try to minimize, you know, that. And then I'm going to draw a rectangle right here. Not to be over my pocket area. So let's get it right up next to it. That's good enough. Okay. This is going to be my vector boundary for nesting. That rectangle is going to be my boundary for nesting. Get this bad boy right on the edge of the board. Make sure you're on the edge of the board. Make sure you're on the edge of the board and all that. That's going to be my area for nesting. So I'm going to take my selected objects, all my individual circles here, right, that are grouped together. Oops, one is not grouped. Group it together. This way the middle circles don't get moved off their position. Okay? So select them. We're almost, guys, we're homeward bound here. Almost there. Okay? Stick with me just a little bit longer. I swear we'll get through it here in the last couple minutes. Okay, we're going to select those first, select our boundary last and everything, and then we could, without nesting, right, we could align them in the center of the last object. They're all stacked on top of each other right now, right? We could then space them, you know, equal spacing and all that stuff, and they're all spaced in there, and that makes no sense. Don't do that. But you could if you didn't have like all of them selected. If I had 4 and 4, I could have done them and all that stuff and spaced them out myself manually, right, using my alignment tool. But what we're going to do is our nesting boundary, we're going to put it on a layer, move to layer, and we're going to call this our nest boundary circles, because we might use it for something else later, who knows, but circles. Stay with me, we're there. And that way, when I select these guys here, and I select this, and I select this rectangle last, in my nesting tool, I'm going to be using a 1/4 inch end mill to cut the parts out. My clearance is how much gap I want between when the router bit is cutting up on the side of one part, the space between the right side of the router bit and the next part, that's the clearance. Okay? So if my bit is cutting up against the wood here, the back side of that bit to the next piece, that's the clearance. Okay? You look at the diagram here. And so I'll go with a 3/8 of an inch clearance. I could go 1/2 inch, whatever, but that's fine. Border gap, I don't want it to be near the borders of this rectangle here, so we'll go 1/8 of an inch. Rotate parts to fit their circles, so it's kind of redundant, but you know, we'll leave it checked. I can't put parts inside of other parts. I don't want to mirror them to fit and everything, and I want to nest from the top corner down that way along the x-axis, and use the nesting boundary is going to be the nest boundary, right? So that's going to be my nesting boundary, and then preview. Right? Now let's undo that, and let's deselect this rectangle and do that again. Preview. Okay. Now, what it's done is it's created a whole separate sheet here and everything because it put it on an active sheet number 2, right? I need to undo that. Okay, active sheet number 1, customize nesting sheets. All right, so use the nesting sheet. I want to make sure I use the nesting sheet. Sheet number 1 here. Don't fail me now, boys and girls. Let's back this off by a 1/16. That's good. That's good. I'm going to make my rectangle a little bit longer. All right, one more time. Nest. Select that. Select that. All my parameters in here. Nest along the Y or the X. Either one doesn't matter. One copy. Preview. Why are you throwing me off into other sheets, boys and girls? I know those parts are going to fit. Bear with me a second, guys. This is not acting like it should. Those parts all day long fit in that piece. All day long they fit in there. So bear with me a minute. Quarter-inch tool diameter. Let's go an 1/8 inch clearance. I just want to see if that shouldn't have anything to do with it. Rotate parts for best fit is fine. Mirror parts we're not doing. Remove original parts. Not sure. Don't need to do that. Yes, do that. Nest from the top left corner. That's fine. Along the x-axis. That's fine. The boundary is this rectangle. See, it used to be selecting the last vector, but now you put it on a layer. That's fine. Nesting sheets. Use active. This is the active. So, one more time, ladies and gentlemen, I'm trying to nest these to minimize my waste and maximize my yield. That's what I'm trying to do right there. Why didn't it work the other 3 times? Huh? Okay. So, maybe because I had too much clearance. But if I had too much clearance, it would have just spread them out in here. Why didn't it work the first time around? I don't know, but that's that. Okay. So, that's those parts. Wonderful. So, those are nested in. I can cut them out of that 3/4 inch material. Now, can I get my other parts, you know, my 4-inch by 4-inch by 6-inch pieces, 6.1968, but can I get them to fit in here? Let me find out. I'm just going to use a rectangle just to take a measurement real quick. So that's 7.5. So got plenty of room for my side pieces to fit into. Plenty of room for my side pieces to fit into. They're only going to be 4 inches tall by length, so I can get both of those in there. My back piece is going to be a different story. The back piece is 12 inches long. So, you know, I could get that in there. I can get that in there. If I rotate, now hold on a second, my side piece, if I put one here, I should be able to, I thought when I did the math earlier that I could get the whole cabinet out of, all the parts out of one cabinet. That there, and then the other one should fit right there in the middle. I am, if you are concerned about grain direction, that would look odd. The grain would be running along this one on this side. It would be running up and down on the other side. So, yeah, aesthetically, that's not going to cut it. Okay. Aesthetically, it's not going to cut it, right? That's fine. But let's do this. Let's move them. If I need to, I can give myself a few more inches. But let's put this here. Let's take this one. And that could go there. And then this rectangle, hey, wherever the parts can fit, right? So I'm going to do a little bit of node editing to change my border a little bit, my boundary, if you will. So what I mean by that is, bump this over just a little bit. I'm going to come in here and add a point and a second point. And I'm going to take these 2 points and I'm going to bump them over. I'm going to insert a point. Insert a point. Take these 2 points, bump them over. And this boundary is going to get moved to my nesting boundary. And I'm going to select these circles first. I'm going to select this boundary last. And I'm going to nest, same parameters. To put those in there. Oh, always hit OK, not cancel. Click OK. All right. So, ta-da. Okay. All the parts are able to get cut out of this one piece. Now, the most important and critical thing is let's do some toolpaths. Okay? Toolpaths. But before we do toolpaths, our 2 side pieces, they get rabbit cuts on the back sides of them. So this rectangle, let's ungroup. U for ungroup. U for ungroup. Okay. This boundary right here, this rectangle, remember, it's already laid out. Okay. Again, we can do some measurement if you want to measure. From our profile line to our inside line, that's 0.385. Where did these numbers come from, ladies and gentlemen? So we got to move this. We're at 0.385. So remember, move. Oops, that's not the move tool. Move. Relative, we're going to the left. It's an x-axis movement to the left. It's a negative number. We are at 0.385 right now. We need to subtract 0.375, the number we're trying to get to, and hit equals, and then put a minus sign in from that. So it's only 0.010 of an inch off, but still, let's shift that to get that 3.375. Okay, let's do the same thing over here. This is most likely the same situation. And it all depends on how good you drew it over in SketchUp. And evidently I missed a few marks there. But 0.376, we just need to .376 is where we're sitting at. So move 0.376 minus 0.375 equals, put a minus sign in front of that and bump it over. Even though it's a small amount, it matters. All right. Pull this out the back a little bit so the bit can clean up this edge. And again, pull the side so it can clean up that rabbit. Same thing here. Pull it out the back a little bit and then pull it out the sides. Hold the shift key. All right, you guys and girls ready for toolpath? This is our last step. We're going to toolpath this and we're going to cut all the parts for this cabinet. Here we go. First cut is going to be a pocket cut. We're going to be cutting 3/8 of an inch deep. Okay, 0.375. We are going to, for the pocket cut, it's going to be the pocket on the top piece, the pocket on the bottom piece, and our 2 back pockets here. I'm sorry, that's a lie. Those do not, those only get 3/16 of an inch pockets. Don't select those. All right, calculate. This is going to be our rabbits for our top and bottom. Top and bottom rabbit. Rabbit. R-A-B-B-E-T. Rabbit. All right. Calculate. Stand by it saying that 2 open vectors were identified. Let me find those real quick. Right click, select all open vectors, and they are open because there's a line that overlaps. So How do we find that? What's the quickest and easiest way to find that is go to node editing mode and look for the green node. So node editing, find the green node. 99.9% of the time, the green node is the one that's overlapping the other line. You see how it's overlapping this line here? Okay. So all I did was just pull it out. I can put it back, you know, and all that. But it's overlapping that line there. That's why it's not closed. So I want to right click and delete this span. And then I want to close this with a straight line. Close with straight line. Oops, not that direction. Close with straight line. Okay, to close that off. All right, same thing over here on this pocket. Find the green node. Pull it, right? Don't pull it like that, but pull that, right? You can see the overlap. So delete the span. And then join with a straight line. Close with a straight line. Okay, now select all open vectors. There's none. Okay, let's get back to where we were. Vector, vector. So 90% of the time, a line has to start. Green node is always where a line starts. Black node is where a line ends. If ever there's an overlap and our vector's open because of that overlap, if you look for the green node, the start of the line segment, you'll generally find where the overlap is. Because if the start and the end aren't coming together exactly, if they're overlapping and all, then it's an open vector. So always look for your start node, and you can find generally where your vectors are open at quickly. Okay, calculate. Okay, nice. All right, so let's come in here and save, file, save as. Let's save this as our building box, building block drawer. Yeah, building block drawer. That's fine. Now that's just the outside. We haven't made the inside drawer yet, but you guys get the concept. We don't really need to go into that. We can lay the parts out on another board, and we can cut the drawer parts. Now the let's turn on the want to see a glitch in the matrix? So the glitch in the matrix is there's no material here. Let's see here. Weird, right? That my board's not there. All right, real quickly, close, save yes, restart it, exit out of Vectric, restart Vectric really quickly. You guys are starting to wind down. We're starting to wind down. It's already 10 minutes past 10. We shouldn't be going this long. All right, open our project back up. All right, let's take a look at our 3D view. There's our board. Good, wonderful. Let's go back here and preview. There's our piece of material. Look how sexy that looks. All right, preview that toolpath to create those pockets, those rabbits. All right, cool beans. Okay, next toolpath is going to be, let's do our drilling operation. So here we're going to drill all the inside circles. So ungroup each of these circles. Try not to accidentally move them, okay? Try not to accidentally move them, but ungroup them so that we can select our inner circles, okay? And these here as well too. Now, these are just for a dowel. They could be however thick you want, however deep you want and all, but remember our top board is 3/4 of an inch thick, so don't go any deeper than that. But I'm gonna go with like a 1-inch dowel, or not, a little less than a 1-inch dowel. So I'll just go I'll go 3/8 and 3/8. I'll go 1/2 inch dowel, so I'll go 5/8 of an inch deep. So we're gonna go 3/8 on the pocket depth. I'm going to use a 1/4 inch end mill. We're going to go 3/8, 1/4 inch end mill. I'm not going to do it as a pocket cut. I'll use peck drilling. That's fine. And we're going to drill our dowel holes. Okay. The next tool path will be these pocket cuts here. And we're going to go all the way through the material. 0.75. And the 1/4 inch end mill, it'll be fine. And calculate. All right. Hit that like button, and hey, if if you're new here and all that, we do have Super Chat down below. Super Chat is a very cool little feature where you can send donations to the creator, and you can have your comment posted at the top of the chat so it's visibly seen. All kinds of neat things if you would like. All right, so that's that. Okay, the next cut. Now, our holes, our circles, right? I'm going to hold down the control key to drag a copy so I'm not moving my circle. But our circles, you know, fit in these pieces, and they're however you want them to, you can size them up or down. I didn't size them at all, you know, to like full size and stuff, because I, you know, just went off so they can sit on top of each other for drawers. But if you want them to snap together, then size your circles up appropriately so they fit in there like a Lego, right? These should fit in here, right? These circles, if I would get them to fit. Would fit in there, you know, and snap together, right? And stuff, you know, on this design, I didn't think ahead, and I had these circles here. When I drew them on the top, I didn't do them the right, so but I'm not going back now. So these circles need to be sized up so they fit inside this these areas better. Basically, You want them to kind of hit the four sides and stuff. Let me see if I can size them up here. I don't know how that got off, but it did. There's nothing I can do about it at this point. And I'm actually going to change that up. I'm going to go back to the original, and I'm going to reduce the size of my pockets. You guys get the idea. Redraw this. I'll have this all cleaned up when I trace the files and all, but I can't go back now. We're already running over time, but these pockets need to be resized. So that 3/4 inch rectangle that I drew, it should have been wider to fit. It should have been wider because the circles actually hit here and everything. So that 3/4 inch rectangle that I drew, it should have been wider. The circle should fit like this in these parts. So my original SketchUp drawing fits exactly like it's supposed to. I did not scale this one properly. This one is scaled properly, and that's my bad. So understand, these parts are going to snap together. They're going to look like this. The parts that you'll get in the files and everything, I'll clean that up. But that's that. Okay. Anyhow, kind of bummed about that, but I don't know what I did wrong, but I'm not going to change it now. Okay. So the next toolpath is going to be these guys here. They're going to get milled down. Remember, they're 3/8 of an inch thick. Okay, these are currently right now 3/4. Okay, so we're going to create an offset, not a big offset, but we're going to create an offset outward, 1/8 of an inch around them. Okay, and we're going to do our next toolpath is going to be a pocket cut on those offsets, milling down 3/8 of an inch. So pocket cut 0.375, calculate, and that is going to mill those back piece and the two side pieces down to 3/8 of an inch. We're almost there, guys. We're almost there. For you faithful few that are still with me, we're almost there. Okay. Our next toolpath is going to be the pocket cuts on the back side of these. Now remember, we just milled this down 3/8 of an inch. So we're going to start at 3/8 of an inch. And we're only going another 3/16. If I come back here to this drawing and everything, and we measure from here to here, 3/16. Okay, so that's how deep they're going to be. So we're going to start at 3/8 and we're going to go another 0.1875 with our 1/4 inch end mill, and we're going to calculate that toolpath. And that's going to create those two rabbit cuts. I don't know why I have yellow. Sorry, guys. That's going to create the pocket cuts on the back side there. And then our profile cut that profile, that profile, that profile. Hold that shift key down, Laney. Hold that shift key down. This profile and this profile. And then all of our circle profiles. I'll go back and redraw this to the correct size and everything. And I'll make it to where you can carve it out of individual boards. I'll just have the parts laid out and you can lay them out on a board how you want. But this is going to be a profile toolpath. Cutting 3/4 of an inch deep on the outside of the line with a 1/4 inch end mill. And you could add tabs and all that stuff if you want. I'm going to just have two-sided tape holding that down, or tape and CA glue or whatever. So we'll calculate that. Preview that visible toolpath. Might cut the circles out before everything else. Oh, we missed a profile here. Hold on a second. Go back into there and make sure that the oops. Bear with me a second. Make sure that's a closed vector. Make sure there's nothing wrong with it. It is. All right, one more time. Let me come in here and select that profile. Not sure what happened with that one, but calculate it again. Not sure what's going on right there. I think because the toolpaths are overlapping. Yep. It's just going right here because it can't fit in between those two profiles. So I need to bump this one up just a hair. Okay. Recalculate. Okay. So there's my parts. Now, of course, I don't have to carve them all out of one board and blah, 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 but this is a 30-inch by 11.25-inch board. I can go up to 36 inches. I could spread things out a little bit more, or I could go smaller and just use multiple boards because I still got to cut the drawers out and things like that. But, you know, I'm going to try to minimize my waste and maximize my yield as much as possible and things. I need my circles when they are attached to the top of the drawer. Now notice here, here's a mistake number one on this is the holes are drilled on the inside of the box here. They need to be, that's not really a mistake. They just need to be drilled all the way through. You're not going to see them on the inside of the box, you know, when it's closed up and all. But that does me no good. These holes only going 3/8 of an inch deep here does me no good because these parts are going to be glued to the top. So on these holes, when on my drilling holes here, these holes need to be put in a separate toolpath. Okay, so it's just those holes on one toolpath and then these holes on another. Because I'm not going to do a two-sided job and flip it over and all that stuff. I'm just going to draw all the way through because, again, you're not going to see those holes on the inside of that dresser. So drilling toolpath, and this is going to go 3/4. on that, so that when it drills all the way through, my dowels go in and those go on there. Okay. So do you get it? Do you get it? Do you get it? Hopefully you get it. I will lay out a design and toolpaths for a drawer with the drawer parts. So this is just the box. We didn't do the drawers, but I will make them available. They'll be available by tomorrow or so. But I will make one for a 8-piece and one for a 6-piece. The drawer. I'll have the files uploaded. They'll be in the download section. You can digitally download those in the description of the video. And something to play with for Christmas, right? All right. Cool beans. So give me a thumbs up if you get the concept. Even though I screwed up on my pegs fitting in these openings here, I got to go back and figure out where I went wrong on that. But these pockets just have to be redrawn. They got to be shrunk down so that these holes fit. That's all. The pockets are just too big, so they need to be reduced down to the proper size. But if you get it, great, good, and hopefully between this and these Lego box project here, between the Lego box project here and between the Lego block project, hopefully you got something out of tonight's class, and you make them. Have some fun with them. I'll get the files to you. They'll be available for digital download tomorrow. But hopefully you can have some fun with them and take some of the lessons from tonight's class and do something else, right? Or just know how to, now you know how to take a millimeter diagram and turn it into inches, right? And then scale it up and all of that wonderful jazz and two-sided machining and things like that. So hopefully something from tonight's class you can take out of it. And for all the super chat users and donators and everything, Calusa cabinets and oh my goodness, hold on a second, my mind just went blank. Brooks Martin, thank you for everything. I appreciate that. The donations help a lot. And you guys and girls, thank you all for sticking with me this long. Good night. Have a great night. Hopefully you get something out of it, right? So, Tom, great question. How can you support me? During the chat sessions, and here I'll show you this on the screen really quick. Let me pull over a window here that you might be able to see. And during a chat session, there is, in the chat, there's this little $sign down here where you can do super stickers or super chat. And a super chat allows you to put a comment, and depending on the dollar donation, your comment, it depends on the duration of how long your comment stays visible and stuff. If you decide to do a super sticker, there's all kinds of cool little stickers for different dollar amounts that you can pop up on the screen and everything, and all of that, those little donations and stickers and all they go, they help go to the channel and stuff like that. And there's all kinds of different ones of the stickers, whatever you're into, little cats and dogs and gorillas and gators and hippos and things like that, but they're all different dollars amounts. And so you can do that. You can buy stuff on buildittv.com/shop, buildittv.com. We have models, 3D models for sale and everything. And so all of that is a great way. Thank you, Tom. There you go. There you go. Tom got the hang of it. But so all of that is a great way to help out the channel, and you know, it just buys wood and materials and ideas and all that cool stuff and all that. But thank you, Tom. I appreciate that. Are you having another open house in Martinsville again? Big Daddy Fish, I think we're actually having a customer training seminar in Martinsville in February. But we are, that being said, we are doing another round of open houses since they were so successful. We're doing another round of open houses in February, and might be in a town near you. You never know. But, and all that stuff. So, Crystal, thank you for your comments. Tom, thank you. Calusa, Roberts, Rodney, everybody, Cecil, JR, everybody, Jim, everybody that you know, that stayed in. Thank you for your super chatters and all that really helps. Rob and everybody, you know, really, I agree. Just being here, viewing, helps out and stuff. And I know it's long, it's late, right? You know, but I appreciate you all and everything. And it's all appreciative. I'll have these files ready for you guys. I'm going to clean them up. They'll be if you go back and watch the video, let's say tomorrow afternoon, probably after 1 p.m. Give me to 1 p.m. You can click on the description of the video, and there'll be a download link there for you with these files with Toolpaths. And I'm going to keep drawing tonight, clean up what I messed up, and which all I messed up was the pocket, the sizes, so the drawers don't fit together, as far as the cabinets and all. We'll fix that, but and then I'll make you a couple of sizes, a 4-piece, 6-piece, and an 8-piece Lego, right, for you to play with. Have some fun. If you make some for the kids or whatever, of different species of wood or what have you, whether it be the drawer or the actual Lego pieces, please share photos. Share photos on Instagram, and you can tag at Build It TV or at Spindle TV. Follow Spindle TV on Instagram and things like that, or shoot me an email, laney.shaughnessy@spindletv.com. Right? Laney.Shaughnessy. I'll put that in the chat here, and I'll shut up because I'm just rambling on now. Laney.Shaughnessy@spindletv.com. That's an email address and everything. But show me some pictures if you do make this, because I'm going to make them, and I'm going to show pictures on Facebook and all kinds of places and stuff. So I'd love to see if you do it too, or do anything like that. All right, everybody. Until next time, y'all have a great night. Have a great week. We'll see you soon. Thank you.